This is RD Sharma solution, class 12th, chapter 9. Continuity exercise is 9.1. What is continuity first? Now this is a road. You're walking, you're riding, or you're driving. The road is straight. You have no problem. You reach your destination. So this road is a continuous road. So the continuity is there because you are reaching from A point to B without any stoppage or breakage. So for any function, for every x there will be y. So every function will have some shape. You can call it as a road. So there can be multiple shape of various functions in mathematics. So what is discontinuity then? You are going, but you have to reach destination B, but there is a breakage. Say, there is a breakage of the road, or there is a bridge which has fallen down. So that part is discontinuity. So continuity and discontinuity, how to know about that? For that, in order to check the continuity or the discontinuity, for that you need to know limits. Limits is the precursor or the background knowledge you must possess in order to actually show whether the function is continuous or discontinuous, right? So continuity and discontinuity is always at certain point, like you see at this bridge. For example, x equals 3, x equals 2, x equals 1. In this case, in this question, it is x equals 0. So you'll be told, please check the continuity at x equals this. For example, x equals 3. The question is been asked. So at this point, how to check? Just move a bit, just a bit, very small. Just move, walk on the opposite direction and front direction, just a little bit, and that we call as h. That h is so small that it can be, it is tending to 0. It is not 0, but it is 0. It is not actually 0, but very, very small distance you have traveled in either direction, and you see, whether it is broken or not. So when you move on the side which you are coming, that is called the left hand side, that is called the left hand limit, and on the right hand side it is called the right hand limit. So you'll add 3 plus h on the right hand side and 3 minus h, because h distance you have traveled on either side. So 3 minus h, 3 plus h, this is called as the left hand limit and the right hand limit. Left hand limit and right hand limit, if they are equal, so you have to go a step ahead. For example, this function. If I try to find out the left hand limit and the right hand limit, for example, x equals 3 we have to check, or x equals to 0 we have to check. Now you have to put that x equals 0 or x equals to 3 in that function. Now that value, if it is equal to left hand limit and right hand limit, that is, left hand limit has to be equal to right hand limit, and that value which is left hand limit and right hand limit has to be equal to the value of the function at that particular point. For example, 8, 8, 8 is coming. For example, LHL, RHL are 8, but the actual value at this function on this x equals 3 is 9. You will say, no, it is not continuous, it is just discontinuous. So the LHL, RHL has to be equal, and the value of that function at x equals to 3 or any x equals k, where you are checking the continuity, has to be equal. Now let us come to this question. So we have to check the continuity of the function at fx at the origin. Origin means x equals 0, y equals 0. So this given, we observe this limit h tends to 0. This all you have to write, because you are actually presenting it to your examiner or your teacher. So this is the way you have to write. I'm going to tell you the logic, the concept behind solution of these questions. Okay? So the question, the background I'm going to tell you, but all these you have to write by yourself. Now, continuity we have to check. So the first thing which I told you was the left hand limit and the right hand limit we have to find out. And what is left hand limit? Because its origin x is equal to 0. So when x is equal to 0, what do? We just go on the left hand side a very tiny bit, that is h. We just go a distance ahead of 0. So 0 minus h and 0 plus h. So x will be equal to 0 minus h in the left hand limit case, and the otherwise case, right hand one, we have 0 plus h. So in place of, now see here, x has changed its value. It is not 0 now. Because when you are subtracting h or adding h, it is not 0. So there are two things given in the function. When x is not equal to 0, when x is equal to 0. So we are going to take x is not equal to 0. Okay? X is not equal to 0, that we are going to take, or that we are going to use. So here, this we have to use. So x divided by modulus x. Here also x divided by modulus x we are going to use. What is modulus, or the absolute value of x? Whatever value you put in here, negative or positive, this absolute or modulus will always give you the positive number. Always you will get the positive number. Okay? So negative to positive, positive to positive. Okay. So x is 0 minus h, put it here, x 0 minus h. Here also 0 minus h. So I hope these all you are going to write by yourself. This is the way you have to actually write. Here on the right hand side, what you are going to do, 0 plus h and 0 plus h here. What is 0 minus h? It is negative h. 0 minus h is negative h, but the modulus or the absolute value will be positive. So it will be h here in the denominator. Here we have h, denominator 0 plus h, h will be h only. Cancel it out, it is negative 1. Cancel it out, it will be plus 1. So what do you see? The left hand limit and the right hand limit, they are not same. They have different value. One is negative 1, one is positive 1. So the first test has failed. The first thing for continuity or discontinuity is left hand limit has to be equal to right hand limit, which is not coming here. That is why this is a discontinuous function at the origin at x equals 0. Maybe at x equals 3, x equals 9, x equals to negative 5, it may happen this function is continuous. But at x equals to 0, it is discontinuous. I'm just giving a fake idea. For example, left hand limit, right hand limit both are 1. And the value of this function at x equals 0, it is already given in here, 1. So if this case is there, left hand limit, right hand limit are equal, and the function value at x equals 0 is also 1, then it is a continuous function. But right now it is discontinuous. It is not continuous. It is discontinuous. A function fx is defined as, I told you there is a x equals 3, we have to find out this is a road, this is a pathway, and at x equals to 3 you have to find out whether this function is continuous or not. At x equals 3 it is given proper value 5, but we will have to check it just behind 3 and just forward, just a bit forward 3. Okay, so how you are going to write? This way. This is the actual way you are going to solve your question. Left hand limit, right hand limit, all these you have to write by yourself, because this is the way you actually answer the question. But as far as I am concerned, I am going to tell you the logic here. So I am going to write the left hand limit, right hand limit, And since x equals 3, we have to check. And since we are taking the left hand limit, we just subtract a very tiny number, very tiny number, which is actually equal to 0, but not 0. I hope you got the idea. So x equals 3 plus h on the right hand limit. And when 3 plus h, 3 minus h, they are not equal to 3. So we have to check, we have to use this function in order to put this x value. So x square minus x minus 6, x minus 3, this is the function you are going to use. So 3 minus h whole square minus 3 minus h minus 6 divided by x is 3 minus h minus 3. And what you are going to write here? You are going to put x equals 3 plus h. So 3 plus h whole square minus 3 plus h minus 6 divided by 3 plus h minus 3. Okay. So let us open this. This is 9 plus h square plus minus 6h. Here you are going to get negative 3 plus h minus 6 divided by 3 minus h minus 3. 3 gets cancelled. You will get negative h. Here you will get 3 is 9 plus h square plus 6h minus 3 minus h minus 6 divided by 3 gets cancelled. You get h here. Okay. So you can cancel these 3, 6 because it is negative 9. 9 gets cancelled. Here also 3 and 6 and 9 gets cancelled. So what do you get? H square, h minus 6h is minus 5h. So h square minus 5h divided by minus h. Here you have h square plus 5h divided by h. Now take h common here. H minus 5 by negative h. Here you have h plus 5 by h. You can cancel this h. You can cancel this h. You have h minus 5. So negative goes up. So just change the sign and write it again. My 5 minus h. Here you have 5 plus h. Now limit h tends to 0. We'll apply it here. This is going to be 5. This is going to be 5 again. So the left hand limit and right hand limit, they are same. They both are 5. That means left hand limit and right hand limit are equal. But there is one more check we have to do. One more level we have to go. That is, at x equals 3, what is the value of this fx? And it is already given in the question that fx at x equals 3, the function f3 is already giving the value as 5. So I told you the limit should exist left and right, left and right, and the value of these limits should be equal to the value at x equals 3 of that function, which is in this case equal to 5. So we can safely say that this function is continuous at x equals 3. A function fx is defined as this. We have to check it at x equals 3. Okay. So x equals 3 we have to check. And what is the value of this function at x equals 3? It is already given. It is 6. At x equals 3, fx is 6. So we will now try to find out the left hand limit and the right hand limit and try to find out whether these two values are equal or not. Okay. So let us see here the left hand limit and right hand limit. The left hand limit, right hand limit, they are equal, and if they are equal to 6, because the value of the function at x equals 3 is also 6, then we'll say it is continuous. Otherwise, we will declare that this function is discontinuous. So let us see the left hand side, LHL, and right hand limit. So what you have to do at point x equals to 3, you have to check. So just put x equals 3 minus h on the left hand side. Because h is very small number. It is not 0, but it is equal to 0. X equals 3 plus h. So what function you have to use when it is not x is not equal to 3? X square minus 9 divided by x minus 3. I am putting x as 3 minus h. Here I am putting in the place of x 3 plus h. So you get this as, see, 3 minus h whole square is 9 square plus h square minus 6h minus 9 divided by 3 minus h minus 3, 3 gets cancelled, you get a negative h here. Here also your 9 plus h square plus 6h minus 9 divided by 3 gets cancelled, you get a h here. So 9 gets cancelled, here also 9 gets cancelled, h common, so h minus 6 divided by negative h plus 6 divided by h gets cancelled, minus goes up, so it is 6 minus h, here also 6 plus h, so h is tending to 0, so this left hand limit is 6, right hand limit is also 6, and since we started with what is the value of function at x equals to 3 for this function, so left hand limit, right hand limit exists, it is equal to 6, and the value of the function is also equal to 6, because that is the next step, but we have already done it. f3 is 6, limits also exist, and that is also equal to 6. That means there is no breakage in the road, and you can draw that function without lifting your pen, right? So actual solution I am showing you right now, and this is how you are going to write. Not what I am writing. I am just giving you all the ideas so that you are aware what exactly is going on. But this is the way you have to write. Given, we observe, LHL, write LHL given, then fx is continuous at x equals 3 with all the computation which you see here. So I hope you got the idea how we are going to find out the continuity and discontinuity. Now here at x equal to 1, we have to find whether this function is continuous or not. That is the pathway or the road which I told you, whether it is broken or it is continuous. Okay. So how do we do this? At particular point x equals 1, first we'll check whether the value of this function at x equals 1, which is given in this question, is what? f1 is given as 2. This is the first thing. Then we will find out the limits, that is the left hand limit and the right hand limit. If the left hand limit and right hand limit are equal, and it is equal to the value of this function at x equals 1, which is 2 in this case, then we say that this is continuous. So LHL and RHL will find out. So in place of x, what we are going to put? 1 minus h. Here we are going to put 1 plus h. 1 minus h, so it will not be equal to 1 then. X is not equal to 1. So we'll put it here. 1 minus h whole square minus 1 divided by 1 minus h minus 1. Here 1 plus h whole square minus 1 divided by 1 plus h minus 1. What this will be? A square plus b square minus 2ab. So 1 square plus h square minus 2h minus 1 divided by 1 minus h minus 1. You can cancel 1 1. You will get negative h. Here a square plus b square plus 2ab minus 1 divided by 1 1 gets cancelled, h it will be 1 1, you can cancel on both sides. This is h minus 2, I am taking h outside. Here also I am taking h common, so h plus 2 it will be. H you can get cancelled. Now negative I am taking up, in the numerator, so 2 minus h. Here 2 plus h. Now apply the limit, h tends to 0, so this will be 2. Limit, and both sides it will be 2 and 2. So what does it mean is that the left hand limit is equal to the right hand limit, which is equal to 2. They are equal, and this is also equal to the value of the function at x equals 1, which is 2. Okay, so this function is continuous at x equals 1. So let me show you how you are going to actually put up, that is, this is the formal way you are going to give the solution. This is how you are going to write. So this fx is now sine 3x by x when x is not equal to 0, and it is 1 when x is equal to 0. So we have to check at x equals 0. So don't worry about the graph of sine 3x by x, because it will be Sin 3x we know already, sin x already we know the graph of x, but sin 3x by x will be different. Okay. So same criteria, same way, left hand limit, right hand limit, and at x equals to 0, that is fx. If x equals 0, it is going to be 1. So left hand limit, right hand limit, we would like to have this number 1. So LHL, RHL. And the point of contention or point of discussion is x equals 0. So what we are going to put it here, x will be equal to 0 minus h, x will be equal to 0 plus h. So I'll just change it, it is not 1 minus h. It has to be checked at 0. So 0 minus h and 0 plus h. Okay. So it is sine. So 0 minus h we have to, because it is 0 minus h, so we will take this case. So 3 0 minus h divided by, in place of h, 0 minus h. Here sine 0 plus h and divided by 0 plus h. So this is going to be sine minus 3h divided by minus h. Since it is negative, so you have to put a negative here. Sine minus 3h. Here it will be sine 3h divided by h. Now by trigonometry and trigonometric identities, equations, we know sine theta, sine negative theta is negative sine theta. Because in case of cos theta, it's reverse. Cos minus theta is cos theta. But sine minus theta is minus sine theta. So you can write it as minus sine 3h divided by minus h. And minus minus you can just cancel. Here it is sine 3h divided by h. So divide and multiply both sides, both numerator and denominator, by 3 in both the case. So limit h tends to 0, sine theta by theta is nothing but 1. So sine this 3 numerator denominator both the cases. This is 3h. So sine 3h by 3h, limit both the cases, it is going to be 1. So only what is remaining here is, because 3 was already outside, so both ways it is 3 on left hand limit also and right hand limit also. But limit exists and the value is also same. But the value at x equals to 0 is 1. It is not equal to 3. That is why we can say that this function is discontinuous at x equals 0. Okay? They both are 3, but the value of the function at x equals 0 is 1. fx is equal to e raised 1 by x if x is not equal to 0, and 1 if x is equal to 0, whether f is continuous at x equal to 0. So fx equals f0. What is the value at 0? It is already given in the question, it is 1. So LHL, RHL, if it comes to 1, then it is continuous, otherwise it is discontinuous. So how do we do this? Remember, discontinuity and continuity is directly related to differentiability. So x equals 0 will check, LHL, RHL. So what is left hand limit? It's x will put as 0 minus h, and on the right hand side we are going to put x as 0 plus h. So we'll use the first one because x is not equal to 0. Soon you put 0 minus 3 or 0 minus h, it's not equal to 0. So e raised 1 by 0 minus h divided by, there is nothing in the denominator, so you can just write on the right hand side e raised 1 by 0 plus h. So here e raised minus 1 by h, here e raised 1 by h. So you can write this e raised 1 minus h by 1 by e raised 1 by h. That is, if you write 1 by x, you can always write it as x inverse, x raised minus 1. So 1 by e raised 1 by h. Here we have e raised 1 by h. Okay, now we are ready to apply the limit. Limit is h tends to 0. Limit is h tends to 0. Okay, so when we get this e raised 1 by h tends to 0, if we apply 1 by 0 is infinity, so it is actually e raised to the power infinity, and e is a constant number 2.732, so we have a proper number, so it is to the power infinity, so that will be infinity only, and 1 by infinite, anything divided by infinite is going to be 0. Here also on the right hand side, e raised 1 by 0, so 1 by 0 is infinity, e raised to the power infinity, same discussion, same logic, it is going to be infinity. Okay, so this is 0 and this is infinity, this is 1, so neither left and right hand limits are equal, nor they are equal to the value at x equals 0. So you can easily say it is not continuous, discontinuous. So same way here, let fx equals 1 minus cos x by x square when x is not equal to 0, and it is 1 when x is equal to 0. So you can check the left hand limit and right hand limit, but you don't need to here, because you can directly use the limit whether it comes to 1 or not, that is at x equal to 0, the value of the function at x equal to 0 is 1. So let us see whether we get the limit or not. If it is mismatched, it is not matching, it is mismatching, then you don't have to worry about finding out the left hand limit and right hand limit. So 1 minus cos x divided by x square, this is fx, and fx, which is x equals 0, you get f0 as 1. f0 is 1. So 1 minus cos x by x square, we'll use the formula. We know that 1 minus cos x, because 1 minus cos 2 theta is 2 sin square theta. 1 minus cos 2 theta or 2 cos 2x is 2 sin square x. So 2 sin square x. So when it is x, 1 minus cos x, it is 2 sin square x by 2. Okay. So just write it as 2 sin square x by 2, and since we have a proper formula like this, 2 sin square x by 2, this is x square in the denominator. Now we know that just now we have seen sin theta by theta, limit theta tends to 0 is nothing but 1. So how can we make it? 2 sin square x by 2 and divided by x by 2 whole square. X square is also already there. In order to make it as square, 2 square is 4. So you multiply and divide by 4. So you get 2 by 4 here. And this is sin x by 2 divided by x by 2 whole square. Same thing here. Now let us apply limit x tends to 0 here. When we apply limit x tends to 0, sin theta by theta is 1. So this is 1. So you can just leave all the right hand side things, because sin theta by theta is 1. We are only left with 2 by 4. Okay. So 2 by 4 is 1 by 2. Since the limit is 1 by 2, but the value of the function at x equals 0 is 1. They are not matching. So the function is discontinuous at x equals 0. If you have to show the continuity, follow left hand limit, right hand limit concept. If you just have to show discontinuous, follow this option. Next one is show that this is discontinuous. So you can again do the same way or apply the left hand limit, right hand limit. It's up to you. So fx equals f2, x is 2. What is the value here? X is equal to 0. Sorry, x equals to 0, it is 2. So when f0 is 2, the left hand limit, right hand limit should be what? It should be 2. Let us see whether it comes or not. So this modulus or absolute value is a machine. That is a machine. When you put any negative value, it will produce always a positive value. So left hand limit and right hand limit we are going to see. What is left hand limit? x is not equal to 0. We'll use this. So x is equal to 0 minus h and x is equal to 0 plus h. H is not equal to 0, but it is 0. It is so small. We can, that is why we are placing it as a limit. Limit h tends to 0. So we'll use this first one, x minus the modulus of x divided by 2. 0 minus h minus modulus of 0 minus h divided by 2. Here also 0 plus h minus 0 plus h divided by 2. 0 minus h is negative h, and since it is a modulus absolute value, it will give you a positive value. It is negative h only. This is the first one, divided by 2. Minus h divided by 2. Okay. Now the next one is 0 plus h minus modulus of h. So positive value will give you positive value only. That is modulus. So 0 plus h is h minus h. It is not negative. Oh, there is a slight mistake. I'll just change it. See, it is h minus h, it is 0. Right hand side, it is 0. So just there is a correction, okay. Left hand side, minus 2h by 2 is going to be h minus h. That is 0. And 0 by 2 is 0 only. Okay. So you get a 0 by itself here. And here when you apply the limit, because h tends to 0, it will be 0 only. So 0, 0 on the left hand side and right hand side. So we have a 0 and 0 here, that is left hand limit, right hand limit are equal. But the problem is the value of the function at x equal to 0 is actually 2, which is not equal to, means these two are not equal. So you can just say that it is discontinuous at x equals 0, right? So this value at function and limit, they are not matching, though left hand limit and right hand limit, they are matching. This question we are going to see in the next discussion, or let us see this one also, okay? Let us see this one also. So this is what we have done already. So f(x), that is x equals to a. So fa is 1, it is already given. So now this left hand limit, right hand limit should come equal to 1 for continuity, otherwise it will be discontinuous. So left hand limit, right hand limit will use. At x equals to a, will check. So x will put a minus h here. X equals to a plus h will put in here. Okay. So you have this. This is the modulus. Modulus is a minus h. I am putting a minus h minus a divided by a minus h minus a. This is the first thing. Then we have an a plus h minus a by a plus h minus a. So a gets cancelled. It's negative h. So its modulus will be positive, minus divided by minus h. Here you can cancel this, h divided by this also you get cancelled, h. So this is 1 and this is going to be negative 1. So minus 1 and 1, they are not equal. So you don't have to go even to check whether the value of the function at x equals to a is what, because left hand limit and right hand limit, they are not matching. And when they are not matching, you can say that this function is discontinuous at x equals a, right? Discuss the continuity of the following functions at the indicated points. Now this 10.1 and all those questions which are following, we will try to find out the limit. Whenever it is required, left hand limit and right hand limit will do that. Otherwise, if we see that the question is such that we don't require LHL and RHL, we just find out the limit and then we can equate it to the actual value of the function. So all these things comes with practice. When you do all these questions number of times, then you will understand when we have to find out the left hand limit and right hand limit, equate it, and then is it equal to the value of the function fx at x equals to 0, or whichever value we have to find out the indicated points at which we have to find out the continuity and discontinuity. So the first step is fx. What is x equals 0? That is the indicated point. So just put x as 0. And since we don't have to do anything, it is already given at x equals to 0. It is 0. It is already given in the question. Now we'll go to the limit. So we are not going to find out LHL and RHL. You will just see why. Because we have a modulus of x already here. So modulus of x, and since the indicated point is 0, and modulus of 0 will always be 0. There is no negative 0. Okay. So 0 into something is always 0. So we can easily find out the limit rather than going to LHL and RHL. But right hand limit and left hand limit, they are required. You will see in certain questions which are coming up that it may be required. But here, I just said that it will need practice. So let me just find out the limit at x equals 0. So when we are saying x tends to 0, because this is x tends to 0, otherwise we would have used h and h tends to 0. Because it is mod x cos 1 by x. And when we apply the limit, modulus x will be what? Limit of a into b is limit of a into limit of b. So you can just differentiate it. Differentiate means, you can separate it. So limit x tends to 0 for mod x and limit x tends to 0 for cos 1 by x. Okay. So leave the right one for now. But what you see here is limit x tends to 0 for mod x. Mod x is mod 0. So that is 0. So whatever is on the right hand side doesn't matter, because it is going to be 0 anyways. Okay. So when you do limit x tends to 0 for 0, it will be 0. So right hand side limit cos 1 by x you don't have to worry about. So RHL, LHL, if we would be finding it, 0 minus h, 0 plus h, modulus of 0 minus h, 0 plus h will be h only. And h is tending to 0. So it will be 0 eventually. That is why we didn't go through that pathway of finding both the limits and then finding out whether it is equal or not, and then finding out whether the value of the function at x equal to 0 is 0 or not. So since we have this, both are equal, limit is also 0 and the value is also 0, this function is continuous at x equals 0. Now next one also we are going to see the same stuff. Just see, this is x square in front and it is at x equals 0. So let us find out the value of the function at x equals 0. What is it? Since f0 is already given as 0. So we'll just find out limit x tends to 0. X square sine 1 by x. Now just separate them. And when we separate them, we see on the left hand side. Right hand side you don't have to worry, that is sine 1 by x. Leave it for now. But limit x tends to 0, x square will be 0. This is 0, 0 square is 0 only. So whatever is multiplied by 0 will always give you 0. So 0, 0 is matching. So you say that this function is continuous at x equals 0. I hope you got the idea. No need to go for RHL and LHL. That is the limits, both sides. And then find out whether it is equal to the function value. Now same here. If you put x equals a in the first part, that is fx equals x minus a sine 1 by x minus a. X minus a, x is a, so it is going to be 0. So we will not go for right hand limit or left hand limit. What I am saying is x equals a, x minus a, x is a, so a minus a is 0. So whatever is 0, it will be 0 whether you do it LHL or RHL. So no need to go for this LHL RHL. Just see that what is the value of function at x equals a, that is f a is 0. Okay. Now limit x tends to a we have to find out. We have to check this at x equals a. So that will be x minus a and then 1 sine 1 by x minus a. let us separate them. So limit x tends to 0 here and limit x tends to 0 here. But what we see here is when we put x tends to a, it is x tends to a, okay. If I said x equals 0, that will be wrong. So right hand side, just forget it. A minus a here, if you put the limit x tends to a, it is going to be 0. And 0 multiplied by anything will be 0. Okay. So the function value is 0, this is 0, so it is continuous. Here the same thing we are going to do. Continuity at x equals 0. The indicated point is x equals 0. Okay. See, the first part is x not equal to a, that you don't have to worry, it is x 0. So just change that question. So f0, that is fx at 0 is 7. Now coming to the limit part. So limit x tends to 0, e raised x minus 1 divided by log 1 plus 2x. Okay, and we have to check it for x tends to 0. So log 1 plus 2x, e raised x minus 1, and we know the certain things which we already learned in our previous discussions and classes. That is limit above and below, that is numerator, denominator will take them separately. So limit x tends to 0, it will be log 1 plus 2x or log 1 plus k, you can assume. 2x is some constant or some value. Now, let me tell you, there are certain equalities or certain results, theorems. So multiply this e raised x minus 1 by x and divide by x. Why I have done this? Because limit e raised x minus 1 by x tends to 0 is 1. This we already know. This we have already proven. The next one is log, if it is x tends to 0, log 1 plus, say it is some k, something divided by k. So log 1 plus k by k, and this is going to be 1. Okay, so 1 plus 2x it is. So just divide by 2x and multiply by 2x. We are doing it for the denominator. So this numerator denominator x you can cancel, and there is 2 remaining, so we can bring it in front. But now when we apply the limit, what do you get? Limit x tends to 0 for e raised x minus 1 by x is nothing but 1. And the denominator log 1 plus 2x by 2x is again 1. As I told you just now. So it is going to be half. So the value of the limit is half at this point, x equals 0. But the value of the function at x equals 0 is 7. So they are not equal. That is, this function is discontinuous. Discuss the continuity of the following functions at the indicated points. Now we have to check it for x equals 1. So we need certain relations. We need to recall all these theorems and proofs we already learned. So here f1, that is fx when x equals 1 is n minus 1. This n is some value in natural number from 1 to 3 like that. So when we apply the limit, this x tends to 1 minus x raised n divided by 1 minus x. Okay. Now just see that you don't have to worry about these. This we have already done in the previous classes. We have opened it, we have used the binomial theorems, etc., etc. But the final relationship is what? X to the power n minus a to the power n divided by x minus a, or you can say a to the power n minus x to the power n divided by a minus x. And when it is tending to x tends to a, the relationship is, it is going to be 1. Or you can write in either way. This 1 can be written as 1 raised n. So 1 raised n minus x raised n by 1 minus x. It is similar to that. Actually what we have learned is x raised n minus a raised n by x minus a, limit x tends to a, and that is going to be 1. But since they are equal, if you take negative outside, it will be same as this one. So when you apply this x tends to 1 in this one, you will get 1. But the value of the function at x equals 1 is n minus 1. We don't know what this n can be anything in the natural number series. So 1 is not equal to n minus 1. That is why at x equals to 1, this function is discontinuous. Right? This is discontinuous. Now discuss the continuity of this at x equals 1. So when we take the fx, that is x is equal to 1, what do we get? We get direct value as 2. So f1 is 2. What about this? There is a modulus here. So when we have a modulus like this, so what the way I am going to tell you, see, modulus x of is always, it will be x when x is greater than 0 or x is positive. It will be negative x, the value of modulus x is negative x when x is less than 0 or x is negative value. So x not equal to 1, the simple way is, if I start with 1, there is a patch from 0 to 1 which is lower than 1, which is not less than 0. So continuity has to be found out at 1. But from 1 to 0 there is a single patch. But below 0 we know that the modulus will be negative. And above 0 we know that it is greater than, since it is greater than 0, it will always be positive. So rather than making it in 3 categories, which you see in the question solution on the left, I am going to make it in 2 parts. What does it mean is that modulus x square minus 1 by x minus 1. So just from 0 till infinity, it is negative. When we open the modulus, it will be negative x square minus 1 divided by x minus 1. But above 0, it will be x square minus 1, because modulus of x square minus 1 will be x square minus 1 divided by x minus 1. So it will be x minus 1 x plus 1 divided by x minus 1. Here so this is negative. This is x minus 1 x plus 1 divided by x minus 1. So you can cancel this x minus 1 in both the cases. You get minus x plus 1 here. Here you get x plus 1. Okay, so whatever value you put. So let us go with LHL and RHL. And we have to check it at 1. So I'm not considering 0 to 1. I'm just saying that below 0, above 0, we have 2 values. That is how we go with the left hand limit and right hand limit. We have to check at 1. Please remember. So I'll put x as 1 minus h. I'll put x as 1 plus h. So it is negative 1 minus h in place of x plus 1. So x I am putting as 1 minus h. So it will be 2 minus h. Negative 2 minus h. Here what we get? 1 plus h plus 1. So this is going to be 2 minus h. There is a negative outside. Here 2 plus h. So minus 2 plus h it is. It is 2 plus h. Let us apply the limit h tends to 0. So here it is negative 2. Here it is going to be positive 2. So the LHL and RHL, they are not coming same. So you don't have to worry about the function value at 2. Okay. The value of f1 is 2. The value of right hand limit is 2. The value of left hand is negative 2. So they are not matching. So you can safely say that this function is discontinuous at x equals 1. Right? Now there is another method which you see in the solution also. But this has to be from 0 to negative 1. Means 0 to plus 1 and like that. So we have to discuss the continuity at x equals 0. So you don't have to worry about anything because it is already at x equals 0. We know that below 0 mod x is negative x. Above 0 mod x is positive x. So the value of this function at x equals 0 is f0, which is 0. This is given already. So we will find out the left hand limit and right hand limit. We'll put x equals 0 minus h in the left hand limit, x equals 0 plus h in the right hand limit. Okay, left hand limit and right hand limit. Okay. Now, this is 2 mod x plus x square by x. So mod x is what? Mod x is x when x is greater than 0. Mod x is negative x when it is less than 0. X is less than 0. Okay. So this 2 mod x, this is mod x. So I am opening the mod x, so I am making it negative. Minus 2x plus x square divided by x, and 2, it is positive now. I am opening the modulus, so you can take x common in both the sides. So 2 plus x by x. Here also you can take x common. You get 2 plus x by x. X you can cancel. It is going to be minus 2 plus x, and right hand side it is 2 plus x. So you can write minus 2 minus x, and it is going to be 2 plus x. Now x equals 0 minus h, just put 0 minus h, so minus 2 minus 0 minus h here. Here 2 plus x 0 minus h. So 2 plus h it is, minus 2, and this is minus will be plus. Now just say h tends to 0 because h is actually 0. It is negative 2, it is positive 2. So don't worry about the value of the function at 0 because negative 2 is not equal. Okay? It is failing. This is the condition which we know for continuity it should be. So this function is discontinuous at x equals 0. Exactly same thing, this question we have already done. X is at equal to a. But since we have a modulus here, what we'll do? Always check x minus a equals to 0 will be what? X minus a will be equal to 0, x equals a. So this a is the point, so below a it will be negative, above a it will be positive. That is the modulus or absolute value theory. So first find the value of the function at x equals a, fx or fa. This is given as 0 here. So the value of the function at a is 0. Now we'll apply the left hand limit and right hand limit, and we'll just open this modulus. And when we open the modulus, as I said, when we open the modulus, it will be negative x minus a and sine 1 by x minus a, because there is no modulus here. On the right hand limit, x minus a will be positive, sine 1 by x minus a. Okay. Now we have to put x as what? Since it is we have to find out the limit, and that also has to be checked at a. So minus x minus a can be written as minus x plus a minus x you can write. Sine 1 by x minus a. This is just a way to write. You can continue with minus x minus a. So x minus a sine 1 by x minus a. Okay. Now left hand limit and right hand limit. Since x is equal to a, the left hand limit will be a minus h. The right hand limit will be a plus h. So x is a minus h here. Here it will be a plus h. So I am putting x as a minus h here. A minus x minus. So I am just writing it here. A minus h, a minus a plus h. A gets cancelled, you get, it's only h. So h here. H sine 1 by, I'm not writing x as a minus h, just you'll see. You have to write x as a minus h in the actual solution. And on the right hand side, x minus a, I'm putting x as a plus h. So again it will be h sine 1 by x minus a. Now you don't have to worry about 1 by x minus a sine, because when you apply a limit h tends to 0, the left hand side and the right hand side, that is the LHN and RHL, both will be 0. So when both are 0, the function value at a is also 0. So all these three are same. That is, the function is continuous at x equals a. Here, the point is 1. That is, you have to check the continuity or discontinuity at x equals 1. And the left hand side and right hand side, that is, the domain is also given. So how do we do this? We will try to find out the left hand limit and right hand limit and see whether they are equal or not. So the point is 1. That is, 1 and below, 1 and above. Since x is greater than 1, x is less than 1 will use 1 plus x square. Greater than 1 will use 2 minus x. And we'll use 1 minus h and 1 plus h because we have to check at 1. So left hand limit, x will be equal to 1 minus h. So we are going on the backward side. So of 1, so we'll use 1 plus x square. Since we are moving in front now, x greater than 1, so we'll use 2 minus x. And what did I tell you? The points, or you can say the limit for limit, will use x as 1 minus h, in this case left hand limit, and RHL will use 1 plus h. Just put it here. 1 plus, in place of x, replace it by 1 minus h whole square. In place of x here, just replace it by 1 plus h. So what will it be? 1 plus a square plus b square minus 2ab. Here 2 minus 1 minus h. So this becomes 2 plus h squared minus 2h. And here we have 2 minus 1 is 1, 1 minus h. Okay. Let us apply the limit now, h tends to 0. So this, how you have to write is on the left side what I have shown you. This is what is the way you have to write. Now coming back to h equals 0, the left hand side, LHL will be 2. Here it will be 1. So, what 2 and 1 are not equal. That means the LHL and RHL are not equal. That means at x equals 1, this is discontinuous. Now we have to check the continuity at x equals 0. Now three different fx's are given. That is, graphically if I can show you, x is 0 here. Now the value of the function at x equals 0 is 3 by 2, which is already given in the question. If we go backward, that is below 0, that is we are going to use 0 minus h in this case for limit. And the function value is sine 3x divided by tan 2x. On the right hand side, when we move forward, of course we are going to use 0 plus h because 0 is the point we have to check. And the function which we are going to use for the 0 plus h, because x equals to 0 is already given 3 by 2. Left is what I showed you. And right hand side, it will be log 1 plus 3x divided by e raised to x minus 1. Okay. So just we have to check at 0 minus h whether this left one is 3 by 2. At 0 plus h whether the right one is 3 by 2. Let us check it. So I'll just write this LHL, this is RHL. Left hand limit, this is, let us apply directly here, x equals 0 minus h, that is minus h we are going to use. Here x equals 0 plus h, so we are going to use h here. So sine 3 is 0 minus h divided by tan twice of 0 minus h. Here what we are going to use? Log 1 plus 3 into 0 plus h, and in the denominator we will use e raised twice of 0 plus h and minus 1. So this is sine, see, I am showing you this one, sine 0 minus h is minus h only. So sine minus 3h it will be. Now we know that sine negative theta is minus sine theta. So minus sine 3h it will be. In the denominator as well, you will get tan minus 2h. What is this? Negative comes outside, so it will be tan 2h. So minus tan 2h it will be. That is tan negative theta is equal to minus tan theta. So minus tan 2h. Negative negative you can cancel. On the right hand side, it is 0 plus h. Of course, h we are going to use. Log 1 plus 3h divided by e raised to h minus 1. Now there are 4 different you can say limit which we need to use, because e raised something minus 1 divided by that something, if we take limit that thing equals 0, that is e raised x minus 1 by x divided by limit that tends to x tends to 0 is 1. So we'll try that there should be 2h in the denominator. Similarly, log 1 plus theta by theta or log 1 plus k by k, theta tends to 0 or k tends to 0, that means it is going to be 1. That we already know by previous discussions. Here also, sin theta by theta limit is 1. Tan theta by theta limit 1. So tan theta by theta limit theta tends to 0 is equal to 1. And this sin theta divided by theta is also equal to 1. So you can cancel this negative sign. So sin 3h by 3h we are dividing, multiplying by 3h. In tan 2h also we are dividing it by 2h and multiplying it by 2h. On the right hand side it is log 1 plus 3h, so we have to divide it by 3h and we'll multiply it by 3h. Denominator e raised to h minus 1 and we'll divide it by 2h. Now just apply a limit, because so we'll just apply limit to all of these functions and you know what will be the value, all will be 1. I'm applying limit h tends to 0 to each and every 4 options which have. This is 1, this is 1. H you can cancel 3 by 2. Here also this is 1, this whole is 1, this whole is 1. H you can cancel 3 by 2. Okay, left hand limit, right hand limit 3 by 2. What is the value of the function at x equals 0? It is already even given in the question, which is given as 3 by 2. So the left hand limit and the right hand limit and the value of the function at x equals 0 is 3 by 2. So the function is continuous at x equals 0. Okay. Find the value of a for which the function f defined by. Now we have to find out the continuity or discontinuity at x equals 0. So x equals 0, what does it mean? See, we have to check at x equals 0. If you go on the opposite side, that is on the backward side, it is a sine pi by 2 x plus 1. On the right hand side or on the forward side, it will be 10x minus sine x divided by x cube. So what we'll do here is, on the left hand limit side, we'll put 0 minus h because we have to check at 0. On the right hand side, we'll check at 0 plus h. Okay. Let us see what it comes to be. That is, we have to apply 0 minus h and 0 plus h. And we will equate them so that we can find out the value of a, because we have to find out when this function will be continuous at x equals 0. So LHL, RHL. And as I said, we will equate them. This is, left hand limit is what? See, 0 minus h will be replaced in place of x. Here also x equals 0 plus h. So that is negative h only, and this is also positive h. Because it is 0, we have to check at 0. So it will be a sine pi by 2 and x will be minus h plus 1. Here we have tan. In place of this x, I am putting h. Tan h minus sin h divided by x cube. Now keep an eye on x cube. We'll do that in a short while. So here, I'll just apply a limit here only because it is sin pi by 2 minus h plus 1. There is only one h. So if you apply a limit, minus h will be 0. It will simply sin pi by 2. So when I apply the limit here, it will be sin pi by 2. And sin pi by 2, sin 90 degrees what? When we apply limit h tends to 0, sin 90 is 1. So on the left hand side limit, we have a only. Okay. So now coming to right hand side. Tan h minus sin h divided by x cube. So just keep an eye on x cube because we are going to replace it by h cube. X has to be replaced by h. So tan will be sin by cos minus sin h. I am taking sin h outside. It will be h cube. I will use it later. So sin h, it will be 1 minus cos h divided by cos h, and 1 minus cos h is 2 sin square h by 2. Okay. And this cos h in the denominator, the sin h by cos h you already know. It is tan h. And tan h by h is 1 if you apply the limit h tends to 0. So what we'll do here is, this 2 I am taking outside. Sin square h by 2 is simply sin h by 2 square. So sin h by 2 whole square. So we need to have h by 2 whole square in the denominator. And we have to have h by 2 in the numerator. That's what we are going to do here. So h square by 4 and h square by 4 here. So 2 we have taken outside. Now let us apply limit here and limit on tan h also. Because tan h by h is simply what? It's 1. We know sin theta by theta is 1. So you can just replace it, sin h by 2 and h by 2 whole square. Now you have 2 tan h and this is h square by 4. So as I said, we need to have one more h. So I am taking 4 here, h, and multiply one more h with h square. That is tan h by h we want, because we will apply the limit, and tan h by h is, we have already seen in the previous question, is going to be 1. And since h square is there, we will multiply it by h, because h we have already introduced in the denominator of tan h. So tan h by h is 1. I am applying the limit here, so just I am replacing it by 1 because we know that tan h by h limit h tends to 0 is 1. Now we have a h cube here, h square into h. But since, if you remember, there is x cube already there, and x cube has to be replaced by what? X cube has to be replaced by h cube. And since we have h square into h, which is h cube, and this x cube is h cube. So now we have, I'm introducing this. I have not used it while doing this. I just told you that I'm going to use it later. So h cube it is. So h square into h is h cube. You can just cancel these two. So you have 2 by 2, 2 by 4, that is 1 by 2. So left hand side it is a, right hand side it is half. So you can just equate a with half, and you can say LHL equals RHL. That means a has to be equal to what? A has to be equal to half. So that is the final value. In order for this function to be continuous at x equals 0, a has to be equal to half. Okay? Examine the continuity of the function at x equals 0. So we'll just do it quickly because x equals 0 and left, right will go left for left hand limit. So we'll use 0 minus h because we have to check at 0. On the right hand side, we'll apply 0 plus h because we have to check at 0 only. On the left hand side, when x is less than or equal to 0, you will use x plus 1, 3x minus 2. On the right hand side, we are going to use x plus 1. So 3x minus h replace x by 0 minus h. That is minus h only. And x equals 0 plus h on the right hand limit. So 3 into, in place of x, it is minus h. So minus 3h minus 2. Here x plus 1, so we have h plus 1. Now apply h equal to 0 as a limit in both the LHL and RHL. So what do you get? You get negative 2 here. On the right hand side, you get a 1. So what do you see? Negative 2 and 1, they are not equal. Negative 2 and 1 are not equal. That means the function is discontinuous at x equals to 0. Okay. Now coming to the graph. What are you going to make the graph? See, these are simple lines. Y equals 3x minus 2. Y equals x plus 1. So you have to make a line. And I hope you will be able to make the line. Because y equals 3x minus 2. Just put the value of x as 0, negative 1, 1. In place of y equals x plus 1, just replace it by x as 0, minus 1, 1. Find out the value of y and just plot it. So these are straight lines. And once you put the straight lines, you will surely see that this is discontinuous. I'll show you this in the next question, what exactly I mean. Discuss the continuity of the function fx at the point x equals 0, where fx is this. So if x is 0, it is 1. That is y equal 1. X is greater than 0, it is x. At x less than 0, it is negative x. So I hope you got the idea. This is just a modulus of x graph that will start from 1, not from 0. Okay, I'll just show you the graph. This is how you're going to make the graph, because in the previous question you have to sketch the graph. This is y equals x, y equals minus x. That is the graph. But it will start at 1. Now coming back to our continuity and discontinuity, we have to check for left hand limit and right hand limit. So LHL, RHL, just replace x by 0 minus h in the LHL, 0 plus h in the RHL. So minus x and plus x. In minus x, this x we have to replace by 0 minus h. It is actually equal to minus h only. And on the right hand side, it is 0 plus h. It is equal to h only. H is very small number which is equal to 0, which is not equal. It is not 0, but it is actually near to 0, very near to 0. So minus minus become plus, and h here also. When we put x as h, now apply the limit, it is going to be 0 here. And this also apply the limit, it is going to be 0. Okay, 0, 0. But LHL, RHL is okay, they are equal. But don't think that this is continuous. Why? Because you will just see that the value of the function at x equals 0 is 1. F0 is 1. Okay. So this is not matching. If it is not matching, what does it mean? It is discontinuous at x equals 0. From graph also you see you have to, there is a sharp turn, and that sharp turn is discontinuity. Now same thing we have to do, but at x equals half. So we have to discuss the continuity of the function f(x) at x equals half. So this is the point half on the front side, on the backward side. So if we are going in the front, that is half to 1, we will use 1 minus x. On the back side we are going to use x. From half, front and back. So LHL will be what? RHL will be what? In left we are going to use x as half minus h. On right we are going to use x as half plus h. Okay. The function what we are going to use? X is half minus h. It is directly x only, so half minus h. Here 1 minus, in place of x replace half plus h. 1 minus half is half only, and because half negative h, half minus h. Now half minus h, apply the limit h tends to 0, it will be half and half on both the sides. So LHL, RHL both half. Same thing we are going to apply it here, h is 0. So half and half. Now you see the value of the function at x equals to 1 by 2 is also half. It is also half. So LHL, RHL and the value of the function at half is all half. So the function is continuous at x equal to 1 by 2. Okay, this we are going to see at the next discussion, or let us do it here only. So we'll use it at x equals 0. We'll do it quickly. So on the left hand side it is 2x minus 1, and here we have 2x plus 1. On this 0 minus h will apply. On this we'll apply 0 plus h. 0 minus h is negative h only. 0 plus h is h only. And just apply it here, LHL, RHL. You know the drill now. So this is twice of x is 0 minus h. Of course we have to write that, because I'm just giving you the logic. The actual scenario you have to write by yourself. So 0 minus h, so minus h, 2 minus h, minus 1. Here we have 2, 0 plus h plus 1. So you have minus 2, minus 2h minus 1, minus, and here 2h plus 1. So h just put as 0, limit h tends to 0. It is going to be one side it is negative 1, one side it is positive 1. And since left hand side, right hand side both are not equal, the function is discontinuous at x equals to 0. Okay, they are not matching. Discontinuous at x equals to 0. This is the final thing which we need to see. For what value of k is the following function continuous at x equals 1? So x equals 1 we have to check. And here x, when it is not equal to 1, when it is equal to 1, it is k. But when we go back and forward, that is x is not equal to 1, then what are we going to get? X square minus 1 by x minus 1. So since k is given in x equals 1, we can directly apply the limit, right? We can directly apply the limit. So just see here, we'll apply the limit and then we'll just equate it to k. So the function value at 1 is k, and the limit is, because we know this limit we have already done, x square minus 1 by x minus 1. This can be written as x square minus 1 square, which is x minus 1, and x plus 1. So the x square minus 1 can be written as x minus 1 into x plus 1, and this is divided by x minus 1, and this is equal to k. So x plus 1 is equal to k, and when we apply the limit, which is x tends to 1, so just replace x by 1. 1 plus 1 is 2, so k is equal to 2. This is your answer. Determine the value of the constant k so that the function this is continuous at x equals 1. The same thing we are going to do here. We'll equate this k, which is actual value of the function at x equals 1, to this one, limit x square minus 3x plus 2 divided by x minus 1. So we are checking it at x tends to 1. So x square minus, you can write it as x square minus x minus 2x plus 2. So this is the numerator I am writing, x minus 1 minus 1 x minus 2, you can take minus 2 x minus 1 divided by x minus 1. So this becomes x minus 2. These are the factor I am making, x minus 2, x minus 1 by x minus 1. You can cancel x minus 1. X minus 2 is equal to k with limit. So when you apply the limit x tends to 1 in this x minus 2, just replace x by 1. This is going to be 1 minus 2. 1 minus 2 is negative 1. K is equal to negative 1. Okay. So k is equal to negative 1. Then for that, this is continuous. This function is continuous at 1. K is negative 1. Now for what value of k is the function? So let us just apply the limit x tends to 0, because we have to check at x tends to 0, x equals 0. Sine 5x divided by 3x, and this is equal to k. Now sine theta by theta, we know limit theta tends to 0 is 1. So sine 5x divided by 5x, and since we have 5x denominator numerator, you both have places you need to have. 3x was already there. So as I said, we have already seen limit x tends to or theta tends to 0, sine theta by theta is 1. Let me write it here. Sine theta by theta, theta tends to 0 is equal to 1. So this whole is going to be 1. We are left with 5x by 3x, and this is equal to k. You can cancel this x out. K is 5 by 3, which is your answer. Determine the value of the constant k so that the function this is continuous at x equals 2. Okay. So this is kx square. You can apply limit here, but now this k is not in the that position where we want, which the question we just did, the earlier questions. So what we'll do here is, if you directly apply here, then also the same thing will come. Okay. Let me just apply it here. So I am applying the limit k x tends to 2 here. It is k into 4 equals 3. So k is equal to 3 by 4. Right? But the thing which I am trying to highlight here is that you have to take the left hand limit and right hand limit, and then you have to put this x as a 2 minus h and 2 plus h in the left and right, and then you have to do the needful. But since the right hand limit, which is x greater than 2, is already 3, it is already 3, so you don't have any x here, so you cannot put any 0 plus h in place of 3. That is why you can directly do it. But the next questions which are coming, you have to find out the left hand limit and right hand limit, and then only you can proceed. You'll see that just now. But here, since it is already 3, so you can just equate it. Determine the value of the constant k so that the function, this type of question we have just completed. So this x equals 0 we have to check. So k is given, the value is k. If you go right or left, this is, which is x not equal to 0, this is sine 2x by 5x. And sine 2x by 5x is what? Say k is equal to, now let us apply the limit. Limit x tends to 0, sine 2x by 5x. So let me write like this, sine 2x by 5x. So sine 2x can be written as sine 2x by 2x. So you have to multiply 2x in the numerator and 2x in the denominator. Sine 2x by 2x, and here you have this 5x in the denominator. So sine 2x by 2x is, limit x tends to 0 is 1. 2x by 5x, x you can cancel, you get 2 by 5. So k is equal to 2 by 5 is your correct answer. So just see it here. How you have to do is this way. Okay. Find the values of a so that the function this. Now, this is x equals 2. So x equals 2. Left, right you have to see. And since it is already given that x less than 2, it is ax plus 5. X equals to 2 also, it is ax plus 5. So when it is x equals 2, it is ax plus 5. When it is less than 2, then also you have to use ax plus 5. And then when it is higher than 2, so you have to use x minus 1. Left hand limit or right hand limit both needs to be computed. RHL, LHL. So left hand limit, you will put x as 2 minus h. H is a very small number which can be equal to 0 but not nearly 0 but not 0. So x is 2 plus h on the right hand side. So we have to put this here. So a into x 2 minus h plus 5. Here x is 2 plus h, so 2 plus h minus 1. Here you'll get 2a minus ah plus 5. And here we have 2 minus 1 is 2. 2 minus 1 is 1, 1 plus h. So 1 plus h it is. And what do you get here? Now you can directly apply the limit. And you can just equate these two. So I'm applying the limit h tends to 0. Here also limit h tends to 0. This gets cancelled. You get 2a plus 5. Here 1 plus h is 0, so 1. So 2a plus 5 is equal to 1. Because the left hand limit and right hand limit you have to equate, right? LHL and RHL you have to equate. 2a plus 5 is equal to 1. So 2a is equal to 1 minus 5, that is negative 4. A is equal to negative 4 by 2. So it will be negative 2. A is minus 2. This is the answer. Prove that the function this. So at x equals to 0 it is given as k. And this remains discontinuous at x equal to 0 regardless of the choice of k. Now this function is always discontinuous. You have to prove that. How do we do this? We have to check this at x equals 0. And the value of the function at x equals to 0 is already given as k. K is some constant. But when it is not equal to 0, when you go a point back, a point forward, then it is x by mod x plus 2x square. But we know that mod x is x when x is greater than 0. It is negative x when x is less than 0. So when we are going backward, x equals 0, we'll take it as negative x. Mod x will open. On right, we are going to open mod x as plus x. So here x by negative x plus 2x square. On right hand side, it will be x by, now since we are on the right hand side, that is above 0, it is plus x. So the best way is to take x common. If you can take x common, so you will get rid of x, both the sides. And 0 minus h will take on the left hand limit, 0 plus h on the right hand limit. So as I said, you can just take this x here and x in the denominator. So when you take x in the denominator, it will be negative 1 plus 2x. So I'm just writing it as 2x square minus x for ease of doing. So this also, right hand side also, I'm taking this, writing it as 2x square plus x. So x, now x in the denominator. So 2x plus 1 it will be. X cancelled, x cancelled, you get 1 by 2. Now apply this 0 minus h is essentially minus h only. So just write minus h here. So it will be negative 2h minus 1. Here 1 by this 2x plus 1. In the place of x, just write h. 2h plus 1. Now since we are only left with this h, no more computation. So apply a limit h tends to 0. Both the sides. This is 0, 1 by negative 1. Here 0, it's going to be 1 by 1. So left hand side is negative 1, right hand side is positive 1. So whatever k is, it doesn't matter, because k can not be simultaneously equal to negative 1 and 1. First condition for being continuous, if a function wants to be, is the left hand limit and right hand limit has to be equal. Okay, k cannot be 1 and minus 1 together. Of course, first 1 and minus 1 has to be equal. Left hand limit, right hand limit has to be equal. Find the value of k if fx is continuous at x equals pi by 2, where fx is this. So this is pi by 2. At point pi by 2 we need to check. And this x is pi by 2. The function value fx is 3. So when you go a bit backward or forward, you will use k cos x by pi minus 2x. This we are going to use in both the cases, on the left hand side and the right hand side as well, right? But on the left hand side we are going to use pi by 2 minus h, and right hand side we are going to use pi by 2 plus h. Okay, so let us apply this here, and this application will be like this. I'm just putting the value right now, k cos, and in place of x I'm writing pi by 2 minus h, and this is pi minus 2 into, in place of x, just replace it by pi by 2 minus h. This is your left hand side. So I'm doing it for left hand limit. Right hand limit, what you are going to do, same thing. Wherever x is there, replace it by pi by 2 plus h. So k cos pi by 2 plus h divided by pi minus 2 into pi by 2 plus h. Okay. Now what we see here is, find the value of k if fx is continuous at x equals pi by 2. Now since it is already given, the left hand limit and right hand limit are equal, so either of left hand limit and right hand limit will work. So you don't have to do right hand limit and left hand limit together. You can leave this right hand limit because it is already continuous. So what is pi by 2 minus h? Cos pi by 2 minus h is sin pi by h. And what is this? Pi minus 2 into pi by 2 minus plus, so plus 2 into h. Okay. So what do you get? This pi and pi gets cancelled. You just get 2h in the denominator. This gets cancelled. You can just cancel these two out. And since we have just 2h in the denominator, just write 2h. Now this sign, now let us apply the limit here. If you want to apply limit, it has to be equal to 3. So k by 2 is constant, so limit h tends to 0, sin h by h, and this is going to be 1. We know that limit h tends to, theta tends to 0, sin theta by theta is 1, and this is k by 2 left hand limit. But since in the question it is already given that this is continuous at x equals pi by 2, so it has to be equal to what? 3. So just equate it with 3. So k will be equal to 3 into 2, which is 6. So k is 6 is the answer for this function to be continuous at x equals pi by 2. Now this question ABC, we have to find out what is the point x equals 0. So at x equals to 0, the value of the function is c, which is some constant. When you go left hand side and right hand side, on the left hand side it is, let me write it here. So I'll just do it. You see there are certain mathematical or algebraic computation we have to do. On left hand side we'll write, or we'll take x as 0 minus h. On right hand side we'll take x as 0 plus h. Okay, x is less than 0, so sin a plus 1 into x plus sin x divided by x. First left hand side we'll do, then we'll go to the right hand side. So sin a plus 1 into, I'm writing minus h because 0 minus h is minus h, and this sin, again x minus h I'm replacing. Denominator x is 0 minus h. Okay. So sin minus theta is minus sin theta. So you have to take minus from both these sign. So minus sin a plus 1 h into h plus, because minus we have already taken, because it is sin minus theta is minus sin theta. So negative h is denominator. So you can take negative outside from numerator. It will get cancelled out from the denominator. So sin a plus 1 into h divided by h plus sin h by h. This, now just apply limit here, h tends to 0, this is going to be 1 plus 1, and this here we have to divide and multiply by a plus 1 just to make it as sin theta by theta. So this whole, when we apply limit here, it is going to be 1 because this is equivalent to sin theta by theta. Only a plus 1 is remaining, so just write it a plus 1, a plus 1 was already there, so this left hand side is a plus 2. Okay, so this left hand side is being done. Now coming to right hand side. Right hand side, it is under root x plus bx square minus root x divided by bx raised 3 by 2. So you can do two things here. Either you replace x by h in the beginning and do the computation, or you can keep it as h or x. It's up to you, right? I'll keep it as x. I'm not going to replace here. First I'll solve this, and then later I will replace it by what? X with h. You can do it in the beginning only. It doesn't matter. Okay. So I'll replace h later. Now you have to rationalize the numerator. So you have to multiply the numerator denominator by under root x plus b x square plus under root x. So numerator denominator is multiplied like this. So this is a plus b minus b. So a square minus b square is x plus bx square minus x. This you get in the numerator. In the denominator you will get bx raised 3 by 2. This is denominator I am writing. X bx raised 3 by 2. And then we have root x plus bx square and plus under root x. Okay. So numerator is simply x gets cancelled. You will get bx square. This is bx square. Just write it here. B into. Now you can replace h here or wherever you want. I am replacing it here only. It's up to you. You can replace it at the later stages also. So x 3 by 2 is what? It is x to the power 1 by 2 is root. And this is x cube under root. What is inside here? H plus bh square plus root h. Okay. Now in these two under root b, these two under root, I am taking under root h outside. So I am taking under root x or under root h, whichever you want, wherever you change. I can take in the h plus bh square h outside, 1 plus bh will be there, and under root h. Both you can take under root h outside. So 1 plus bh will remain here, plus because root h is already been taken out, only 1 will remain. So you have a root h here. So h, see, root h you have already taken outside, and it has to be multiplied by h to the power 3 by 2 and b. So this h root of anything is that to the power half. So h half, that is a root h I am writing, and h to the power 3 by 2 was already there. Half plus 3 by 2 is 4 by 2, which is 2. So h square you will get. So I am just writing h square here, which I am going to cancel it with h square in the numerator. bb also gets cancelled. So in the denominator what will remain is simply under root 1 plus bh plus under root 1. This is what is remaining. Now apply the limit here. Limit h tends to 0. So h to x, x to h, you can just replace it here in the beginning or in the later part. It's up to you. Now this bh will become 0. So under root 1 plus under root 1 is 1 plus 1 is 2. So 1 by 2 it is. Okay. Now 1 by 2. Now left hand limit has to be equal to right hand limit. What was left hand limit? Remember a plus 2, we just did the left hand part. The right hand limit is half. So RHL and the LHL has to be equated. One is a plus 2, one is half. So a plus 2 equals half. So a is equal to half minus 2. That is going to be 1 minus 4 by 2. And that is going to be minus 3 by 2. Now we have got the value of a. A is minus 3 by 2. C already we got as this half. C is half. A is minus 2 by 2. C is half. What about B? There is no way we can find out B here. Can you find B? No. So B we have to see from the initial fx. Under root x plus bx square minus under root x divided by bx to the power 3 by 2. So if b is 0, this fx will be something by 0, which is undefined. So b can be any real number except 0. There cannot be 0 in the denominator. So a is minus 3 by 2, b, c is 1 by 2, b is real number minus 0. Now here we have to find out the value of k if fx is continuous at x equals 0. So the same way we are going to do that. That is, the point is x equals 0 And what is the value of the function f(x) at x equals to 0 is given, which is half. When it is not 0, if you go left or right hand side, then you have to take 1 minus cos kx divided by x sin x. Okay. So we'll just try to find out the limit, and that value of the limit will equate it to half. So why I'm doing this? Because I know this 1 minus cos kx by x sin x can be deduced or can be solved to an extent where we can apply directly the limit without getting 0 or infinite or something, right? Okay. So 1 minus cos kx by x sin x. Now let me tell you one thing. People they generally say you are seeing the solution and just solving it. See, the solution is being shown just that how you are going to write. And what I am suggesting is concept, the logic, how you have to do it. Because if this kind of question comes to you again or any of this sort, you will be able to solve it. Okay. So 1 minus cos 2 theta is basically 2 sine square theta. So that is 2 theta, it becomes theta. In 1 minus cos kx, kx can be assumed to be theta, and we will divide it by 2 when we come to 2 sine square. So 1 minus cos kx, it is 2 sine square kx by 2. Kx is whole theta, so kx by 2. Now here we have x sin x. So let me do it shorthandly. This x is already there, sin x is there. So sine square kx. This is nothing but sin kx by 2 whole square. And when we divide it by kx by 2 whole square, what will happen? Sin theta by theta form will be there. So sin kx by 2 whole square. We have to divide this kx by 2 whole square and multiply the same in the numerator. So why we have got this? Why we have done this? Because sin theta by theta we need to find out. Whether it is square, cube, doesn't matter. It has to be sin theta by theta. Now what is sin x here? It is sin x. So we need a x in the numerator. So we'll multiply 1x in the denominator as well. Now we'll apply the limit. When we apply the limit, what do you get? See, limit x tends to 0. This sin theta by theta is going to be 1, and sin x by x, limit, this is also going to be 1. Okay. Now the x by sin x is equivalent to sin x by x in the denominator. So this whole part, both of these is 1. What is left? 2. This is x square, and we already multiplied by kx by 2 whole square. So I am just opening it, k square x square by 4. Now x square gets cancelled, 2 2s are 4, k square by 2 is what is left with us. Now since the limit is equal to the value of the function at x equals to 0, in order to show that it is continuous, since it is continuous, k square by 2 is equal to half. So what do you get? K square equals plus minus 1. 2 gets cancelled, it is under root, k is under root 1, which is plus minus 1. If fx is this, now there are 3 partitions, or you can say 2 partition along 4. So 4, this is 4, x equals 4, fx is given as a plus b. When you go on the left hand side, it is going to be x minus 4 divided by modulus of x minus 4. If it is x less than 0, and this is plus a. When we go on the right hand side, it is going to be x minus 4 divided by modulus of x minus 4 plus b, right, when it is x greater than 4. So these are the situation. So left hand limit and right hand limit we are going to find out, and we will equate it to a plus b, and we'll try to see whether we get a or b or not. So I am going to start with left hand limit, and simultaneously we'll also see the right hand limit as well. So left hand limit, what is there? If we are going on the backward side, it is going to be 4 minus h, because we have to check at 4. Right hand side, it is 4 plus h. So x minus 4, in place of x, I am going to replace it by 4 minus h. x is 4 minus h, it is x equals 4 plus h. Just put it here. So 4 plus h in place of x minus 4 and modulus 4 minus h minus 4 and plus a. And here x minus 4 plus h I am writing. Minus 4 divided by 4 plus h minus 4 and plus b. Okay. Now this 4 gets cancelled. You have negative h divided by, here also 4 gets cancelled, h by. Now coming to the denominator. Denominator is modulus. When you cancel 4 and 4, it is negative h. Modulus or absolute value will always give you positive. So you will get an h in the denominator. Okay. Here h in the denominator plus a. Similarly, on the right hand side, means RHL, what are we going to get? H by h. Let me complete this. This is minus 1 plus a, so a minus 1 you can write. Similarly, on the right hand side, 4 gets cancelled. Modulus of h or absolute value of h is directly h only. So write it h here, plus b. Now you can cancel this out, b plus 1 it will be. So b plus 1. So left hand limit and right hand limit are equal. And in turn, they are equal to the value of the function at x equals 4. So a minus 1 is equal to b plus 1 and that is equal to a plus b in order for this function to be continuous. Right? So let us equate it to a plus b. So we'll take first and third first. So a minus a1 equals a plus b. A gets cancelled. B is equal to negative 1. Then a plus b equals b plus 1. bb gets cancelled. A is equal to 1. b is minus 1. A is equal to 1. These are the values. So this is your answer. B negative 1, A 1. For what value of k is the function this? Continuous at x equals 0. So this is sine 2x by x. Just make it as sine 2x by 2x. Take the limit, equate it to k. So I can easily foresee the answer. It is 2. How? Because I'm just taking the limit and you just have to do like this, sine 2x and x is there. So it has to be equal to the value of the function at x equals to 0, which is k in this case. So limit of that function, if it is equal to the value of that function at that point where we have to check the continuity, then we say it is continuous. Since it is given continuous, we are dividing it by 2, multiplying it by 2. Sin theta by theta, we already know that it is going to be equal to 1. So k is equal to 2. Now fx is given like this. X is not equal to 0. Because if x is equal to 0, it is going to be division by 0 and that is not acceptable. Find the value of f at x equals to 0 so that the function f becomes continuous at x equals 0. Okay. What we are going to do, we are just going to make this fx, we'll try to find out the limit and just equate it to the f0. f0 is what? The value of the function at 0. We don't know what it is not given as k or anything else. We'll just call it as f0, right? Okay. So the first condition which is already given to us is that this function is continuous. So f0, the value of the function at 0 is equal to the limit of this function at x equals 0. So limit x tends to 0, fx. This we have to compute and that is going to be f0. That is the value of the function at 0. Okay. So before we go ahead, this is log 1 plus x by x. When we apply the limit x tends to 0 for this kind of relationship, this is equal to 1. We have already seen that multiple times. So this is log 1 plus x by a divided by, I am separating this. So x here in the denominator and minus log 1 minus x by b. Again x in the denominator. Okay. Now 1 plus x by a. So you need x by a in the denominator. Because I already told you log 1 plus x by x or log 1 plus k by k, limit k tends to 0 is 1. So what we need is just, you don't need to do this 1 plus x by a or whatever, it is just x by a. So you need to multiply this a in the just to eliminate this, because you are introducing it by yourself, so you need to eliminate also. This is x by b, and since it is negative, so you have to have a negative b in the denominator, means negative x by b it should be there. So for that you have to multiply negative b also, just to eliminate this. So now let us apply the limit. Limit extends to 0, it will not change. Limit extends to 0. Now this, just keep this in mind. So log 1 plus x by a divided by x by a is going to be 1. Log 1 minus x by b divided by minus x by b is again going to be 1. Okay. So what do you get? 1 by a here and minus 1 by minus b. See, there is a negative already and we have multiplied by negative b, so it will be plus. Negative will become plus. So 1 by a plus 1 by b, and that is going to be your f0. You are equating it to f0. So you can write it as b plus a divided by ab. That is going to be your f0. This is your answer. Now fx is this term. At x equals 2, it is already given as k. So whatever comes when we apply the limit, it has to be equated to k. So the continuity has to be checked at x equals 2. So we have to find out k. So we'll just find out the limit, and that limit value is equivalent to k. So 2 raised x plus 2 minus 16 divided by 4 is x minus 16 it is. So we will just try to simplify it and try to cancel out whichever is possible. So I'm writing 2 raised x plus 2 as 2 raised x dot 2 raised square, because the power gets added, minus I'm writing it as 2 raised square. 2 raised square, it is basically 16. 2 raised 4, it is 16. 4 raised x. So I'm writing 4 raised x. 4 is 2 square. So I can write it as 2 square to the power x, or 2 raised x to the power square, or 2 raised to the power 2x. They all are same. Whichever we would like, we'll just write like that. Minus, since it is 16, so 4 square it will be. So in the numerator, I am taking 2 square outside. 4, so 2 raised x minus 2 square, so 4 will remain inside. Here what we'll do? Now I am writing this 2 raised 2x as 2 raised x to the power 2. And since we want square, so square can be taken outside. So 2 raised 2x can be easily written as 2 square to the power x, which is nothing but 4 to the power x, which is already given in the question. So 2 raised x square I am writing. A square minus b square it has become. So a minus b. A is 2 raised x, b is 4. So a plus b, a minus b you can use, because it is a square minus b square now. So 2 raised x minus 4, 2 raised x plus 4. Why we have done this? Because we can cancel these two things. Now let us apply the limit. 4, 2 raised x plus 4. Apply limit x tends to 2, because the continuity has to be checked at x equals 2. Now 4 divided by 2 raised 2 plus 4. 4 by 4 plus 4 is 8. So 4 by 8. So you have half. So k is equal to half it is. Because k is equivalent to this value. K is equal to half. So k is half is the answer. This is how you have to do this. Now this is cos square x minus sin square x minus 1 divided by under root x square plus 1 minus 1. So first one is when x is not equal to 0 and x equal to 0, it is k. So whatever continuity we have to find out at x equal to 0, we will try to find out the limit. Limit has to be equated to k. So essentially you have to only find out the limit, and that limit value will be equal to k. Basically, if you are well versed with finding out the continuity, this question is for you. And all the questions here are for you, because it's all about finding out the limits, nothing else. So continuity is directly related to your limits. So first, numerator cos square minus sin square minus 1. Now we know that cos square is 1 minus sin square x, because cos square x plus sin square x is always, when you add them, it is going to be 1. So cos square is 1 minus sin square x, 1 gets cancelled, the numerator will be minus 2 sin square x. Okay. Now denominator, let's take the denominator. Denominator we have to, I've just taken the numerator. Denominator we have to rationalize. Rationalize means what? Under root x square plus 1 plus minus 1 and just multiply this by under root x square plus 1 in the numerator and plus 1 in the denominator. Okay. Now this is a plus b, a minus b in the denominator. So a square minus b square, root gets, you can just remove this root. So x square plus minus 1 in the denominator, under root x square plus 1 in the numerator. A 1 gets cancelled. Numerator denominator we got. So minus 2 sine square x under root x square plus 1 divided by x square it is. Oh, very good. Sine square x is already there. X square is we have got in the denominator. And just apply the limit. Sin x by x is sin x sin theta by theta. Theta tends to 0 is always going to be 1. But it is sin theta by theta whole square. So let us take the limit we are applying. Sin square theta, sin theta by theta whole square. Okay, I am just removing it. You have to apply it properly, okay. Now minus 2 remains. Now let us apply x equals, because x equals 0 here. So 0 plus 1 is 1, under root 1 is 1. And you have a 1 here also. So under root 1 plus 1 is going to be 2. Okay, 2 is there, negative 2 is already outside. So it is going to be negative 4. So k will be equal to what? Negative 4. Answer is negative 4. Because we equated it finally. Extend the definition of the following by continuity. We have to check at x equals pi. X equals pi we have to check. Okay. So we just have to find out the limit of this function at x equals 5, and that is going to be your f pi. Remember we have done a question just like that at f0 just now. So f pi. So extend the definition of the following by continuity. So find out the limit, equate it to f pi, and that is going to be your answer. Please remember 1 minus cos theta is 2 sin square theta. So we'll apply it here. 1 minus cos 7x minus pi is 2 sin square 7x minus pi divided by 2. Whatever is the value after cos, just divide it by 2. That is you have to do. 2 sin square 7x minus pi by 2. And in the denominator, we have 5. So I'm just taking 5 outside. And we have x minus pi whole square. Oh, since we need x minus pi already whole. See, sin square, whatever is 7 by 2, don't worry about that. X minus pi whole square is also there. So it can be remembered as 7x minus pi by 2 whole square it is. And we need x minus pi in the denominator's whole square, which is already there in the question. And 7 by 2 is not there. Because sin theta by theta is going to be 1 when we apply the limit theta tends to 0. So x minus pi whole square already there. We just need to introduce 7 by 2 whole square. So 7 by 2 whole square is what? 49 by 4. So 49 by 4 I am introducing. But still I am introducing myself. I have to eliminate it as well. So I need to multiply this by 4 by 94 in the denominator. I hope you got the idea. So this is now sin theta by theta. So this is limit theta tends to x tends to pi, and this is going to be 1. Only 4 by 49 in the denominator. So all we have done, 2 by 5 was already there, 4 by 49 is in the denominator. Keep 4, take 49 in the upstairs, and then 2 gets cancelled. 49 by 10, f pi is 49 by 10. So finally, the value of f pi is 49 by 10. Okay. So this is the extending the definition of this. If fx is this, x is not equal to 0. If fx is continuous at x equals 0, then find f0. So f0, see, first is limit x tends to 0. Then we apply limit x tends to 0, and we can see that sin x by x is 1. Limit x tends to 0. So the best way is to divide the numerator and denominator by x. So this is the fx or function which we are talking about. 2x plus 3 sin x divided by 3x plus 2 sin x. And since we can divide the numerator and denominator by x, the x gets eliminated and we'll get sin x by x. And we know that limit x tends to 0, sin theta by theta or sin x by x is 1. So we will divide the numerator and denominator by x. So I'll show it to you here only. Let's divide by x, divide by x, divide by x. So what do we get? X gets cancelled. 2 plus 3 sin x by x here. Here we have 3 plus 2. Again sin x by x. Now we can apply the limit here. Limit x tends to 0. Let's apply it here. Limit x tends to 0. So limit x tends to 0, limit x tends to 0 here. This sin x by x is going to be 1. This sin x by x is going to be 1. What do we get? 2 plus 3 into 1, 3. Here 3 plus 2 into 1 is 2. So 5 divided by 5, which is going to be 1. And that is equal to your f0. This is your answer. Now this kind of question we have done, find the value of k, for which fx, because we have to, it's already given that it is continuous at x equals 0. When we have x equals 0, it's k. If you go back side or front side, it will be 1 minus cos 4x by 8x square. And we know that there is a relationship 1 minus cos 2 theta is 2 sine square theta. So whatever is there with cos divided by 2. So you have 2 sine square. This is 4x by 2 is 2x. Then this is 8x square. So you can write it as 2 into 4x square. Now 2 you can cancel. And this is sine 2x divided by 2x whole squared. So this is whole squared. And now you can apply the limit. Limit is x tends to 0. And since sine theta by theta, as we have seen in various questions now, that limit x tends to 0 for sine theta by theta is 1. So this is 1 square. And you have to equate it with what? The value of function at x equals 0, which is k. So k equals 1. Now the answer I showed you, this is how you are going to write exactly while answering in your exam or in your classwork. Now almost same kind of question here. So let us do it quickly. We have to equate it by 8. Okay. Now rather than going for left hand limit or right hand limit, we can see that we can devise this or formulate this in a way where we can easily solve it using the limit. So this is 2 sine square, 1 minus cos 2ks is 2 sine square. Whatever is this 2ks or theta, you have to divide it by 2. 2 sine square kx, and this is x square. Now just in k square, I'm having it here or introducing in the denominator, so you have to write in the numerator as well. So 2k square I am bringing in front. This is sine kx by kx whole square. So sine theta by theta, limit theta tends to 0. This is going to be 1. Okay. So what do you get? You have 2k square. This is twice of k square. And what is 2k square? It is given in the question that it is equal to 8. So limit x tends to 0. Fx is equal to f0. That is the value of the function at 0, which is 8 in this case. So 2k square is 8. K square is 8 by 2, which is 4. So k is plus minus 2. This is the answer. In each of the following, find the value of the constant k so that the given function is continuous at the indicated point. X equals 1, k. X not equal to 1, this one. Okay. So there are ways you can do it. First, I'll tell you a way in which k will come as a different number. So let us start with the way which is very normal. X minus 1, 10 pi x by 2. And we can just apply the limit here. And we know that when we apply the limit, x tends to 1. and we can change this x minus 1. This we are going to do in the actual solution also. So x minus y you have to put as, say, y, or any variable you can take. So x will become 1 plus y. So in place of x minus 1, write y, and 10 pi. In place of x, write y plus 1. This goes here, so y plus 1 it will be 1 plus y divided by 2. Okay. Now limit will change because it is x minus 1 equals 0, so x tends to 1. So y will tending to 1 minus 1, that is 0. So limit y tends to 0 you have. And we know that this tan theta by theta, limit theta tends to 0, is going to be 1. We already seen that. But are we going to get the exact result? Let's see what do we get. So we have y, and this is 10 pi 1 plus y by 2. Now divide the denominator by 1 plus y by 2 and multiply by 1 plus y into pi by 2. That is, you have to include that also. Now why we have done this? Limit y tends to 0 here. So this whole term tan theta by theta is going to be equal to 1. So what do you get? When you apply the limit, you will get y, and you have pi 1 plus y by 2. Now the limit is existing. If you apply limit y tends to 0, what do you get? Just apply y tends to 0 or y equals 0. You'll get whole as 0. So what you'll do is, you will say, oh, k is equal to 0, because you are going to equate it with fx. And what is x at fx? f1. So f1 is going to be k. Okay. Now the scenario here is, you will get k as 0. Now the exact solution is not like that. So this is the only way which everyone will try, because k is 0 in this kind of solution. That is wrong. So I'll give you the actual way how it needs to be done. See here, this x minus 1 equals y. You have to take this x minus 1 equals y. That is going to remain same. That won't change. So this x will become y plus 1. Those steps are will go on like that. So limit y tends to 0, and y tan pi. So pi, this is 1 y plus 1 by 2. Now you see here, we will use this pi by 2. So I am writing this 10 as 10 pi y by 2 plus pi by 2. So it is 10 pi by 2 plus theta. And what is tan 90 plus theta? It's cot theta. Tan 90 plus theta is going to be minus cot theta. So you have minus cot pi y by 2. Okay. You have a negative, because tan 90 plus theta is minus cot theta. Cot is what? Cos by sine. So cos pi by y and sine pi by y, pi y by 2. Okay. Now let us, we know that cos pi y by 2, if you apply the limit at y equals 0, we'll get a 1. But limit sine theta by theta is 1. So you have to, cos 0 is 1. Sine pi y by 2, we can change it to sine pi y by 2 by pi y by 2. Cot theta, cot 0 is 1. So we can apply the limit in the numerator. For denominator, we will divide it by pi y by 2, multiply by pi y by 2. This is all going in the denominator. So now we apply the limit. Limit theta, this y tends to 0. This is going to be 1. And this also is going to be 1, because it is cos 0. Cos 0 is 1. Okay. So what is remaining? Minus y divided by pi y by 2. Y gets cancelled and 2 goes up. So it is going to be minus 2 by pi. So this is going to be equal to k. So this is the actual way in which this question needs to be done, not in the way the solution I just gave you few seconds earlier. In each of the following, find the value of the constant k so that the given function is continuous at the indicated point. So cos x we have, k into x square minus 2x we have, and we can apply the limit also, but without even applying the limit we can even solve this. So let us see how we are going to do this. Because x equals 0, if x is less than 0, then we have to use k into x square minus 2x, it is less than 0. When it is greater than 0, we apply what? It's cos x. And we will apply 0 minus h and 0 plus h in the left hand side and right hand side respectively. First, we have to equate it. Now, whether it is having a continuity or not, let us see. LHL is, we are putting x as 0 minus h. RHL, we are placing it as x equals 0 plus h. So, k into, in place of x, I am putting minus h, because 0 minus h is minus h only. So, minus h whole square minus 2 into minus h. On right hand side, we have this cos 0 plus h is h only. So, cos h. Here we have k, this is h square minus 2h. So, plus 2h actually. So, even if you take h outside with k or let it be inside h, it's eventually, if h is tending to 0, this is going to be 0. On right hand side, cos h, see left hand side I told you h is 0. So, anything you multiply with 0, you get 0. But right hand side, when you apply h as 0, cos 0 is 1. So, the left hand limit and right hand limit, they are not equal. So, when the LHL and RHL are not equal, there is no question about the continuity because it is discontinuous, right? So, this function, because find the value of constant k for this to be continuous, but it is not continuous. When it is not continuous. So, if you try that direct, you can apply this direct limit here also, but you can try this, you won't get the answer. That's why it has to be done like this. In each of the following, find the value of the constant k so that the given function is continuous at the indicated point. Okay, so same thing we have to do here is left hand limit, right hand limit, and then just equate it and try to find out the value of k here, right? So this is LHL and RHL. LHL I am writing here, RHL here, and this has to be found out or computed at x equals pi. The point of contention, or you can say the continuity check, is x equals pi. So when you go a bit backwards, you have to use kx plus 1 because it is x less than 0. When it is x greater than pi, then you will use cos x. Less than kx plus 1, right cos x. So x is pi minus h you are going to use on the left hand side. X is pi plus h you are going to use in the right hand side. So k in place of x I am writing pi minus h plus 1. On right we are going to use this pi plus h. So cos pi plus h. Now cos 180 plus theta, either you use h equals 0, it is going to be cos pi. Cos 180 is minus 1. Or you can say cos pi plus theta is minus cos this value. Or you can simply say cos 0 is 1, cos 180 degree is minus 1. So eventually it is going to come as negative 1. This is the right hand side. Cos pi is minus 1. What about the left hand side? It is k into pi minus h plus 1. You can have h as 0. Either you can open it k pi minus kh plus 1. It is going to be this is going to be 0. So k pi plus 1. Now k pi plus 1 has to be equated to negative 1 because LHL is equal to RHL. So k pi plus 1 is equal to negative 1. 1 goes there. So k pi is negative 2. K is equal to negative 2 by pi. Right? This is your answer. In each of the following. So these are all same kind of question. One of it we are going to do a different way. But here we have x equals 5. So we have to check at x equals 5. And if you go a bit backwards, x is less than 5. You are going to use kx plus 1. When you move a bit further, you have to use 3x minus 5, and x equals 5 is the point of continuity check. So x will be equal to 5 minus h on the left hand side, x will be equal to 5 plus h on the right hand side. So let us apply this. We'll find out the limit and we'll equate it. So k into, in place of x write 5 minus h plus 1, and here 3, in place of x write 5 plus h minus 5. It is 5k minus kh plus 1. Here you have 5 is 15 plus 3h minus 5. Now you can apply the limit here. Limit, what is limit? Limit h tends to, see, it's h tends to 0 because we have already used x as 5 minus h. This cancel these out, 5k plus 1, here also cancel this out, 15 minus 5 is 10. So left hand limit, right hand limit you have to equate, 5k plus 1 equals 10, and you get 1 here. So 5k is equal to 10 minus 1, that is 9, k is equal to 9 by 5. This is your answer. Now this one also same way, in each of the following find the value of the constant k so that the given function is continuous at the indicated point. So you don't need to go through that LHL and RHL. Why? Because we can see that x square minus 25 can be written as x square minus 5 square, and x minus 5 x plus 5, that is going to be cancelled. X minus 5 gets cancelled. So I will directly do it using final limit rather than going for those left LHL and RHL. So limit x tends to, see, directly apply limit x tends to 5 here. You have x square minus 25 divided by x minus 5. So you have this x minus 5, x plus 5, because 25 can be written as 5 square. X square minus 5 square is x minus 5 into x plus 5. Divided by x minus 5, you can just cancel this x minus 5 and x plus 5 will remain. This x plus 5, apply the limit, x tends to 5, it is going to be 5 plus 5 is 10. Now this has to be equated to k. So what is this? Left is 10 and you can equate it with, because value of function at 5 is k. So k is 5. K is 10. This is your answer. Now let us check this at 1. It is kx square 4. Now LHL and RHL you can do. But I think that direct application of the limit can also give you this solution, because k into 1 square, k is directly 4, I can see that. But x equals 1, let us go the actual way. X is equal to 1 kx square. If you go forward, it is kx square. You move backward, it is going to be 4. So how do we apply limit at 4? Because it is a constant value. You can apply only the limit when we have certain x. You can apply x as 0 minus h or 0 plus h, then you can move forward. But this is already a constant. So just apply the limit x tends to 1. It will be k into 1 square, that is k. And since we have to equate it with the left hand limit with the right hand limit, k is equal to 4. Directly you can do this. But in order to show the examiner that I have already checked left hand limit and right hand limit, and then we have equated, and that's how k has come as 4, that you can also do. So basically what I'm trying to insist here is that while you are solving, you have to go through that whole procedure of k, LHL and RHL. But directly if you see that the answer comes like that and there is no untoward number which is going to come if you apply the limit, because the limit is only applied when you don't get a proper answer. The answer is 0 by 0 or infinity by infinity, like that. But here there is no problem. Even if you apply the limit, it is going to be same, k into 0 plus h, this 1 plus h square, 1 square plus a square plus b square plus 2ab. H is eventually 0, so it is k square, k into 1 square only. It is going to be equal to 4, because 4 is a constant. We don't have any x here. In each of the following, find the value of the constant k so that the given function is continuous. K into x square plus 2 here, and 3x plus 1. So x as 0, it is kx square plus 2. If you go behind or backwards, it is kx square plus 2. If you move forward, it is going to be 3x plus 1. So x is going to be equal to 0 minus h here, 0 plus h on the right hand limit. So k into, I am writing minus h in this place, minus h square plus 2. Here we are going to write 3 into 0 plus h is h only, plus 1. So this is, you can apply limit here only, it's not going to affect anything. When we apply the limit h tends to 0, both way I am applying the limit. So this is going to be both way. Okay, so this is 0, so twice k it is. Here 0, so you get 1, 2k is 1, k is 1 by 2. This is your final answer. In each of the following, find the value of the constant k so that the given function is continuous at the indicated point. Now x is equal to 2, at x equals to 2, the function is continuous. So when you go left or right, this function we have to use, which is when the x is not equal to 2. So when x is equal to 2, this is k. Now how to do this? This expression holds the key. That is, you need to know how to divide the algebraic expression, how to factorize it. So whatever limit we compute, we have to equate it with k. So limit x tends to 2 fx, which is the function which we are talking about, is equal to f2, which is k in this case, right? Let us solve it. So we have x cube plus x squared minus 16x plus 20 and divided by this numerator. Since we have x minus 2 whole square in the denominator, it is not x minus 2 into x minus 3 in the denominator. So we know that, or we can deduce that x equals to, we can check for the numerator. Okay. For example, denominator x minus 2 into x minus 3 will check for 2 and 3 both. But here we have the number which is x equals 2. Let us check it. So in this expression, I am placing 2. I am replacing x by 2. So what do we get? 2 cube plus 2 squared minus 16 into 2 plus 20. This is 8 plus 4 minus 32 plus 20. 20 plus 12 is 32. 32 minus 32 is 0. Okay. So x equals 2 is that basically x minus 2 is a factor. So how can we write x minus, this first expression, the numerator expression? When we have x minus 2, what will be the remaining part? There are different methods you can do. Those who are able to do it by themselves, it is very good, because that is the whole key of this question. But I will divide this expression by x minus 2 to get what is the remaining factor. So x cube plus x square minus 16x plus 20. X minus 2 we are dividing. So this is x square multiplied by x square, so that you get x cube. So you multiply this by, this is simple division of algebraic expression. So we need x cube, so x square multiplication, you get x cube minus 2x square. Okay, now subtract these, change the sign and subtract, means subtracting means change of sign. So you will get 3x square minus 16x plus 20. Now we need 3x square, so multiply this by 3x, so you get 3x square and minus 3 to the 6x. So this also you can change the sign, because you are subtracting 6 minus 16 is minus 10x and you have plus 20, right? So now we need 10x, actually negative 10x, so minus 10 multiply, minus 10x and minus minus is plus 20. So now you can cancel these two out because you are subtracting, it will be 0. So what is the next factor? The factors of x cube plus x square minus 16x plus 20 is x minus 2 and x square plus 3x minus 10. So this factor we can easily find out. We know that 5 2s are 10 and 5 and 2, if they are subtracted, you will get a 3. So x square plus 3x minus 10 it is. So I'll just change it. It is not plus 10. It is minus 10. So let me just change it now. So I'm not doing it right now. I'll just change it, okay, because it is minus 10. So there is a slight mistake. Let me just cancel this out. Yes, this is minus 10. Okay, so let us do the like this. Let us do like this. X square, it is negative 10. X square plus 5x minus 2x minus 10. So x plus 5 minus 2x plus 5. So you will get x minus 2 into x plus 5. So now you have two factors here, x plus 5 and x minus 2. Now replace x square plus 3x minus 10 by this, x plus 5 into x minus 2. So numerator we have x minus 2 and x plus 5. In the denominator you have already x minus 2 into x minus 2, that is x minus 2 whole square. So you just cancel this out. So only remaining thing is x plus 5. Now let us apply the limit x tends to 2 in x plus 5. So applying 2 here, 2 plus 5 is 7. So the limit of this function is 7. Limit is 7, right? Now equate it with k. So k is equal to 7. This is your answer. So let me tell you again, this is the main key factor of factorizing it. Find the values of a and b so that the function f given by fx, this, is continuous at x equals 3 and x equals 5. So what do we do here? We have, let me just make an arbitrary graph. It is not the graph of this function because basically x plus b is a straight line. But I'm just for understanding, in this type of question, for example here 3 and 5. So we have to check the continuity at 3 and 5 both. We have been checking for one value, but now we'll check it for 2. So you have to do 2 iterations, one for 3, one for 5. Okay. So how do we do this? We'll start with x equals 3. So this is a point 3, x equals 3. And we move back because x is less than or equal to 3 here. It is a constant. So it will always remain a constant. It doesn't have any x. So putting any value for the limit or not putting won't affect. But the right hand side, if you go above 3, it is ax plus 5. So we'll take the left hand limit, right hand limit, we'll equate it. So left hand limit, right hand limit. What is this? X equals 3 minus h will put in the left hand limit. X equals 3 plus h will put in right hand limit. But we'll only target the right hand side because we already know there is a constant here. So where do you put x? There is no x with the constant. So it will always remain as 1. On the right hand side, it is ax plus 5. In place of x, replace it by 3 plus h. Is it ax plus 5? No, it is ax plus b. Oh, slight mistake here. I did a mistake. I am correcting it. It is ax plus b. Please remember, we are putting x equals 3 plus h in place of x. But this is not ax plus 5. It is ax plus b. So there is a slight correction. I hope you will be, doing that. Okay, now this a, you can multiply this 3a plus ah plus b. Now just apply the limit here, h tends to 0. When you apply the limit, it will be 3a plus b because ah will be 0. Now you have to equate this now. Left hand limit and right hand limit you have to equate. So 3a plus b is equal to 1. This is what you have to do, right? So this is your first equation from x equals 3. Now, since the continuity has been already declared, it is continuous at x equals 3 and x equals 5. So we'll do it for x equals 5. Left hand limit, right hand limit. So if you go back, it will be ax plus 5. If you move forward, ax plus b again. I'm sorry for this b, I'm again and again saying 5. So ax plus b, and right hand side we have there's no value, only constant is there is no x, so just you can place it as 7. Okay, so you have left hand side as ax plus b. So by 5 minus h on the left hand side, 5 plus h on the right hand side. So we will put this a in place of x, we are going to replace it by 5 minus h. So a 5 minus h plus b. So 5a or a5 minus ah plus b, will apply limit here. This h tends to 0, this ah will be 0. So 5a plus b it will be. So what it will be? It will be equal to 7. 5a plus b is equal to 7. So 3a plus b equals 1. 5a plus b equals 7. So 3a plus b equals 1. Just cancel this out. You have a 2a. 2a is equal to, this is 6. So a will be equal to 3. Okay. Now just put it here. 3 into 3 plus b equals 1. B is equal to 1 minus 3009. It is going to be minus 8. Negative 8. A is 3. B is negative 8. This is how you solve this type of question. I hope you'll be able to solve this kind of questions now, because plenty of questions are coming like this. Okay, we have to check because we have to show here. It is not given already. We have to show that this function f is continuous at x equals 1. So x equals 1. When we move a bit backward, it will be x square by 2 we are going to use. Just behind 1, you can say. A step back from 1. So left hand limit will use x square by 2 and 1 minus h we are going to use here. On right hand side we are going to use 2x square minus 3x plus 3 by 2, and in this case we are going to put x as 1 plus h. Okay, 2x square minus 3x plus 3 by 2. So x equals 1 minus h here, x equals 1 plus h here. Okay, so h tends to 0 here, h tends to 0. So 1 minus h whole square divided by 2. You can open it also. If you don't want to open h, you can place 0 here only, because when you open it using square a minus b whole square, it is going to come h, wherever h comes it will be 0 anyways. Okay, 1 by 2 it will come. I have placed h as 0 here. Here again 2, 1 plus h whole square minus 3 into 1 plus h plus 3 by 2 twice of now you can place h 0. Similarly, the same way we did just now, you can replace this h by 0. So limit h tends to 0. This is 2, h is 0, so 2 1 into 1 square is 1 only. It will be actually 2 minus 3 plus 3 by 2, because eventually everything is 1. We have this leverage here because it is 1 plus h and 1 minus h, that is why. So 2 minus 3 plus 3 by 2, 2 plus 3 by 2 is 2 to the 4 plus 3 by 2, that is 7 by 2, and subtract it with 3, so 7 minus 6 divided by 2, it is going to be half. Now you see, this is also half, this is also half, right? Okay, now is this done? No. Left hand limit and right hand limit are equal. This is fine, but still we have one step still remaining, which is the value of the function at x equals 1. LHL and RHL are equal, but we have to check it for the function at x equals 1. So f1. What is the value of the function at 1? It is x square by 2. Replace x by 1. 1 square by 2 is 1 by 2 only. Now all the three values are equal. That is why this function is continuous at x equals 1. Discuss the continuity of the function fx at the indicated points. These are the, see, these 39.1 etc. These all questions are having modulus in it. So whenever you get the modulus or the absolute value, we are going to check this function for 0 and 1. But modulus value is positive x when it is x greater than 0. It is going to be negative x when x is less than 0. Right? So this is very clear. If you are very clear about this concept, all these modulus questions, because in competitive exams most of the questions are related to this modulus. So we have to check at x equal to 0 one time, and then later we'll check for x equals 1. So x equals 0. So x will put 0 minus h, x will put as 0 plus h for left hand limit and right hand limit respectively. Just put this LHL and RHL. In place of x, just replace it by 0 minus h. So 0 minus h, this is 0 minus h plus. In place of x, just put 0 minus h. Minus 1 is already there. Okay, coming to right hand limit. Now place 0 plus h in place of x. So mod 0 plus h and plus, in place of x, 0 plus h minus 1. Okay, what is this? 0 minus h is minus h. Minus h is h only. Modulus of minus h is h. Here minus h minus 1. What you can do is you can take minus common. You can say h plus 1. And when the modulus is removed, it will be positive. So plus h plus 1. Basically it is 2h plus 1. But we will just apply the limit. On this side, right hand limit, 0 plus h is h only. So mod h, it is h only. Plus 0 plus h minus 1. So when we open this modulus, you can apply limit here also, or you can replace it by h minus 1 when you open this. Because when you apply this h as limit here on this case only, it will be negative 1 will be positive 1 when it comes out of the modulus. So now apply the limit. 2h plus 1 is 1. Here h is 0, so it will be 1. So left hand limit and right hand limit, they both are coming as same. Okay, at x equals to 0. Now you can put 0 at that point also, because you need to have the value of the function at x equal to 0 also coming as 1, and you can just verify it. The second case is x equals 1. Same thing we are going to do. On the LHL we will put 1 minus h, RHL will put 1 plus h, right? So in this mod x plus mod x minus 1, in place of x, replace it by 1 minus h. So 1 minus h plus x, so 1 minus h minus 1. And here you'll replace it by 1 plus h. So mod 1 plus h plus mod 1 plus h minus 1. So now this 1 gets cancelled. 1 minus h is 1 minus h only. This is get cancelled. Minus h will be positive h. Here 1 plus h, let it be like this. And 1 gets cancelled. You get mod of h. So now just apply the limit. H is 0. Mod 1 is 1 only. So 1 plus h. H 0. Mod 1 is 1 only. I am applying limit h tends to 0 both the sides. So mod 1 is 1 only, 1 plus h. Now apply the limit h tends to 0. It will be left hand side, it is going to be 1, right hand side also 1. So in both the cases, at x equals 0, x equals 1, both the cases LHL equals RHL. So the limits are equal. Okay, so we can very well say that this is continuous, because we need to check at x equals 1 in this also. So let me just give you the final verdict, because we have to check for x equals 0. So mod 0 plus mod 0 minus 1, what do you get? You get mod 0 is 0 only, because f0 we have to also find out, f1 also we have to find out. So this is going to mod 0 is 0, 0 minus is minus 1, and mod of minus 1 is 1. So these all three are matching. Then we say it is continuous. Here also we'll check. What we'll do, in place of x, we'll replace it by 1. So mod 1 plus mod 1 minus 1, 1 minus 1, and this mod 1 is 1, plus 1 minus 1 is 0, so 1 it is. So this one is equivalent to this one, and this is also similar to this one. So all these three are matching. Then only LHL and RHL won't work. You have to also show that the value of the function at this point is also same as LHL and RHL. I hope you got the idea. Okay. Discuss the continuity of fx at the indicated points. Now these points are -1 and 1, and function is also given, and it includes the modulus, that is the absolute value. Absolute value means if you have modulus of x, it will be positive x if x is greater than 0. It will be negative x if x is less than 0. So this you have to keep in mind. Let us check at -1 and 1. So I'll do one of it. Let us take, because we have to check at -1, left hand limit and right hand limit will follow. The point is x equals -1. So if you go a bit, behind, or you can say you step back, it will be -1 minus h. If you move forward or you step in front, it will be -1 plus h. This h is very small number, it is equivalent to 0, not 0 but it is equivalent to 0. So minus 1 minus h for left hand limit, minus 1 plus h in the right hand limit. So let us do it. So mod, in place of x just replace it by minus 1 minus h, and there is minus 1 already, plus in place of x again minus 1 minus h, and plus 1 is already there. So let us do this. Minus 1 is minus 2. So negative 2 minus h it will be. And this will be 1, negative 1. You can cancel it out. Minus h plus. Okay. And this you have to keep in mind. So negative h will be positive h when it comes out of the modulus sign. You can write this minus 2 minus h as minus 2 plus h. And inside this, when you have a modulus, the positive sign will come out. So it will be 2 plus h. So this is 2 plus h, that is 2 plus 2h you can write. But eventually when you apply the limit h tends to 0, this is going to be 0, so only 2 will come, right? So left hand limit of this discussion is 2. Now coming to the right hand limit. So wherever x is there, we'll put minus 1 plus h. So minus 1 plus h I am putting in place of x. Here also minus 1 plus h plus 1. Okay, so here we have minus 2 plus h plus 1 minus 1 you can cancel, it will be h. So plus h is already h, and you can apply limit here also, or you can, because we don't know what will happen when we take it outside. So minus 2 it will be h, I am applying limit here only. So h is 0 of course, and when negative 2 will come out of the modulus, it will be 2. So you see here, left hand limit and right hand limit are same. Okay. So now we have to do one more activity. What is that activity? We need to put this minus 1 in this function and check whether the value comes to 2 or not. So I am just placing minus 1 here, minus 1 and minus 1 plus 1. And this gets, this 1 minus 1 is 0. So modulus of 0 is of course 0. Minus 1 is minus 2. So modulus of minus 2 is 2. Okay. So 2, 2, 2. Left hand limit, right hand limit. And the value of the function at negative 1, they all are 2. So you can safely say that it is continuous at x minus 1. Now I want you to do this x equals 1, and I hope you'll be able to do it. This is the same way you have to do. Prove that fx equals this is discontinuous at x equals 0. So x minus mod x divided by x at x equals 0. So when you go a bit, step back, I'm just saying step back because we are going to use h. So at x equal to 0, f0 is already given as 2. This is already given in the question. So you don't need to check for that. You just have to see left hand limit and right hand limit. What will be the limit? Or you can directly find out the limit. See, limit x tends to 0. What do you get? X minus mod x by x. But what do you get here? There will be some problem. Because this mod x at x, you will put minus h plus h like that. So we will do what? We'll use that modulus fundamental here. So when we have a point which is just behind 0, it is 0 minus h. In front of 0, it is 0 plus h. So let us replace this mod x by 0 minus h in this case. Because when we replace x which is lower than 0, it is negative x. Above 0, it is positive x. So x minus of minus x is x plus x divided by x. X, this is 0 of course. This is 2x by 2. X gets cancelled. So it is constant. So even if you apply limit, what will happen? Nothing will happen because it is constant coming. The left hand limit is 2, right hand limit is 0. They are not equal. So you don't have to check for any other thing because this is discontinuous at x equals 0. Next one is, see, both the functions are almost same for x greater than or equal to 0 and x less than 0. They are almost similar, but there is a negative sign also. For this, we have to check at x equal to 0. So 2x square plus k when x is greater than or equal to 0. So when we go on the right hand side, it will be 2x square plus k. When we go to the left hand side, it is going to be minus 2x square plus k. These are the two functions you have to use. What should be the value of k so that fx is continuous at x equals 0? So let us see what is k. Do we get value of k or let us see. So left hand side and left hand side, RHL and LHL. So x is 0, you have to check. So use 0 minus h on the left hand side, 0 plus h on the right hand side. Now just put here 2 in place of x. 0 minus h, I am putting minus h. It is similar. Minus h whole square plus k. On here right hand side I am putting h. So 2h square plus k. So this is negative 2 minus h square is of course h square plus k. Here you have 2h square plus k. Okay. Now apply the limit. Limit h tends to 0. Limit h tends to 0 here also. So when you apply limit, you see both sides it will be k only. K is equal to k. So left hand limit and right hand limit are equal. But what about k? So we'll check the value of the function at x equals 0 also. And this is the equality sign. The first one. 2x square plus k. So 2x square plus k. So x 0 I am putting 2 into 0 square plus k, which is k only. So this k is value of the function at f0 at 0. All these three are k. So first of all it is continuous. But how to get the value of k? We don't know. So we just have to give the answer that k can be any real number. This is the biggest set we know. We are not going to any other set that is higher than real number. Real number is the set we just talk about. For what value of lambda is the function this? This is the function. It is continuous at x equals to 0 and we'll check for plus minus 1 also. So first of all, x equals to 0. Let us see what do we get. Because we are not going to get anything. X equal to 0. You have to use what? Lambda x square minus 2x. So let us see the left hand limit. Let us see the right hand limit. In left hand limit, we'll put x as 0 minus h. Right hand limit, we'll put x as 0 plus h. This is lambda x square, that is I am putting minus h only. So here also you can put h only. So minus h whole square and minus 2 into minus h. And on the right hand side, we'll do the left, right hand side, but left will complete. This is h square. H square minus is plus 2h. Now I'm just showing it to you, but we can see that h is already there in both the term and lambda is outside. So even if you take h outside common, it will be h plus 2 inside. So whenever you put h tends to 0, the whole term is going to be 0, so you won't get any lambda. All will be 0 because lambda is in multiple with h, and whenever you multiply anything with 0, you'll get 0 only. So how about getting lambda? You won't get it. Okay. Let us see the right hand limit also, then you will realize 4 h plus 1. So limit h tends to 0. Now when we apply the limit, this is 4 into 0, that is 1 only. So it will come as 1. Now 0 it is, 1 it is. So when we put x equal to 0 in this function, that is f0 I am finding, it is the f0 I am finding, because we need to check for all of these. Let LHL, RHL and also the value of the function at this. The lambda is 0 square minus 2 into 0, that is again coming to 0. 0, 0, 1. So it is not continuous which we see here, but we cannot say anything right now. So we cannot get the value of lambda in case of x equal to 0. I hope you got the idea. You cannot get the value of lambda here at x equal to 0. Continuity, discontinuity, you can see that it is discontinuous. 0, 0, 1 it is coming. It has to match. Okay. Now let us come to x equals plus minus 1. So either I'll take plus or minus, because 1 I'll leave it for you. Plus 1 I am leaving it for you because minus 1, whenever it is negative, it is somewhat more effort to be done. So I'll do minus 1. x minus 1 we have to check. See, what we have to see is, this is x equals, this situation is at 0 because the question is given as 0. But when we talk about x minus 1, we are actually talking about way beyond 0. That is on the left hand side of 0. That is, you can easily put, I'm taking minus 1, right? X at minus 1. So left hand limit, you will put minus 1 minus h. There is no modulus, so don't worry about that. Just put minus 1 minus h. On the right hand side, you have to put minus 1 plus h. X equals minus 1 plus h. Okay. Now, because x less than 0 is lambda into x square minus 2x. So lambda, in place of x, write minus 1 minus h whole square minus 2 into minus 1 minus h. Right? Okay. So let us do this left hand side first. So minus 1 minus h, I am taking minus common, 1 plus h you can write, it is squared. So minus square is plus 1 plus h square. I am taking minus from here, so there is already negative 2, so it will be positive 2. Positive 2 into 1 plus h. So negative whole square is positive. So you have to do 1 plus h square. So a square plus b square plus 2ab. So 1 plus h square plus 2h. Minus minus will be plus, so 2 into 1 plus h. So 2 into 2 plus 2h. So 2 plus 1 is 3. 3 plus you have 4h plus h square. And you have a lambda also. Now let us apply the limit. Limit h tends to 0. So these 2 will be 0. It will be 3 lambda. We will get some value here. Okay. Just see the right hand side. It is minus 1 plus h. So 4 into h minus 1 I am writing 1 plus 1. 4h minus 4 plus 1. The limit h tends to 0. This is going to be 0. 1 minus 4 is negative 3. This is going to be negative 3. Okay. So left hand limit should be equal to right hand limit. 3 lambda has to be equal to minus 3. So lambda will be equal to negative 1. That is the value you will get when x is equal to minus 1. I will encourage you to do it for plus 1 also by yourself. But one more thing is remaining. We have to check it for f minus 1. The value of the function at negative 1. What it will be? Lambda, because x less than or equal to 0 we have to check. Lambda minus 1 whole square minus 2 into minus 1. Lambda minus 1 whole square is 1. Minus minus is plus, plus 2. So it is going to be 3 lambda. Okay. 3 lambda minus 3. When you equate it, what do you get? 3 lambda equals minus 3. Same case. Again you will get minus 1 only. Lambda minus 1. But in case of x equal to 0, you don't have anything to check or equate it to lambda, because lambda itself was coming as 0. Right? So x equal to 1 you have to do by yourself. For what value of k is the following function continuous at x equals 2? So we have x at 2 we have to check. So x equals 2, and just a step back and step forward. X is less than 2, x is greater than 2. Both the functions are given, 2x plus 1 and 3x minus 1. Both are given. Okay. So we'll find out the left hand limit and then the right hand limit, and then we'll equate it to k. So LHL will take, because we have to check at 2, so we'll take 2 minus h. RHL will take 2 plus h. Okay, and what is the function? 2x plus 1, so 2 into 2 minus h plus 1 it is. Here 2, because it is 3x minus 1, so 3. 2 plus h minus 1. Okay, let's do this one. 4 into 2, this is 4 minus 2h plus 1, 6 plus 3h minus 1. Just apply the limit. Limit h tends to 0. Both sides. So this minus 2h is going to be 0. This 3h is going to be 0. So this is 4 plus 1 is 5. 6 minus 1 is 5. So of course this is 5, this is 5, and it has to be equal to the value of the function at x equals 2, that is f2. And that is equivalent to k. So k is 5. K is 5 here. Okay. So fx continues at x equals 2. K is 5. Now this is function fx, and x equals 5 by 2 we have to check. Right. So fx is continuous at x equals pi by 2. Find a and b. So pi by 2 we are going to check. And pi by 2 minus h. If on the left hand side we go, right hand side we go, we will take pi by 2 plus h. And since we have both the functions being given, and a when it is equal to pi by 2. So we'll do one by one. We have limited space to write. The left hand limit is LHN. Okay. So x equals pi by 2 minus h we have to write. Pi by 2 minus h it is. And which function we are going to use? 1 minus sine cube x divided by this 3 cos square x. So 1 minus sine cube, and since this is it with division. So 1 minus sine cube pi by 2 minus h it is, and in the denominator what we get? 3 cos square pi by 2 minus h. Okay, please remember sine pi by 2 minus h is cos h, sin 90 minus theta is cos theta, and cos 90 minus theta is sin theta. So cos pi by 2 minus h is sin h. Okay, so let us change it. 1 minus, this is 1 minus cos cube h, this is 3 sin square h. Now just assume it to be 1 cube so that we can apply the formula of a cube minus b cube. What is a cube minus b cube? It's a minus b, a square plus b square plus ab. A minus b, a square plus b square plus ab it is. Okay. So we have 1 minus cos h here. And here we have a square, that is 1 square, plus cos square plus 1 into cos h. 1 into cos h, okay? Okay, let us apply it here. So we already have 3 here, so we'll use this 3. And this is sin square h. Sin square h we can write it as 1 minus cos square h. 1 square you can write. So 1 square minus cos square is it's 1 minus cos h, 1 plus cos h. Okay. So 1 minus cos h you can cancel it out. 1 by 3 was already there. Now let us apply a limit. Please remember cos 0 is 1. Sin 0 is 0. But cos 0 is 1. So this is 1 plus 1 plus 1. And denominator we have 1 plus 1. So 1 plus 1 plus 1 divided by 1 plus 1 it is. Okay. So 1 by 3 was already there. So 3 by 2 into 1 by 3. 3 gets cancelled. You get half. Now this is half this left hand limit. Please remember it because we are going to use it because it is actually equal to a. So directly from here you can say a is 1 by 2. Because we are going to equate this with f pi by 2 and f pi by 2 is given as a in this question. And the left hand limit is half. Coming to the right hand limit, it's x equals pi by 2 plus h. b into 1 minus sin x. So we'll use pi by 2 plus h here. And in the denominator we have pi minus 2x whole square. So in place of x, so pi minus 2 into pi by 2 plus h we are going to use here. Pi by 2 plus h. And this is whole square. This whole square. Okay. So this x was, I just replaced it with pi by 2 plus h. Now sin 90 plus theta is what? Add sugar to coffee. Sin 90 plus theta will be, this is going to be cos, but it will be in plus. So 1 minus cos h it will be divided by, so what we are going to get in the denominator, pi minus 2 into pi by 2, so you get 2 gets cancelled, and minus 2h, so this gets cancelled, pi gets cancelled, you have minus 2h, and minus 2h whole square it will be. So 4h square it will be. In the denominator you have 4h square. Now you see this 1 minus cos h, because 1 minus cos 2 theta is 2 sin square theta, right? So 1 minus cos h can be written as 2 sin square h by 2. This is 2 theta, so it will be theta. 2 sin square h by 2. And we have in the denominator 4h square. So you can write it as 2h square, or you can have a h by 2 in the denominator, h by 2 whole square. You can divide it and multiply by h by 2 whole square. H by 2 whole square denominator, h by 2 whole square in the numerator. Okay. So what do we get? 2b sine square h by 2, and as I just indicated you, it was 4h square. So this is 2b by 4h square into sine square h by 2. You can have in the denominator h by 2 whole square, numerator also h by 2 whole square. This sine h by 2 by h by 2 whole square, you can apply the limit. It is going to be 1. We have seen already in multiple questions here. This is going to be 1 after applying the limit. So 2b by 4h square into h square by 4. So this is 4. So this is 2. H square cancel. 2 to the 4. So it will be b by 8. So a was half, and a can be equated to what? You can equate it, right? So half is b by 8. So b is equal to 4 and a is equal to 1 by 2. So this is fx, and f pi by 2. Of course, in the previous discussion I already told you just now that this is a was already, we found it to be half. This is how a is half and b is 4. See, in order to solve all these questions, this trigonometric relationship, this you need to recall or remember a lot, because what we have seen here is a lot of sine cosine things happening. If the function fx defined below is continuous at x equals 0, find the value of k. Fx is given like this: 1 minus cos 2x by 2x square, k and x by x bar. So x is less than 0, so if you go left, it will be 1 minus cos 2x by 2x square. If you go right, it is going to be x by x modulus, or absolute value of x. So we'll go left. We have to check at x equals 0, so LHL, RHL. Left hand limit will use 0 minus h in this case, and 1 minus cos 2x by 2x square is the function, and 0 minus h, here x will be equal to 0 plus h. Function will be x by modulus of x. Okay, so let us do this one. 1 minus cos 2x, so we will put minus h here. So 1 minus cos twice of minus h divided by 2 and minus h whole square. So this cos minus theta is plus cos theta, as sine minus theta was minus sine theta. So cos minus theta will be equal to cos theta, right? So 1 minus cos 2h divided by 2h square. What is 1 minus cos 2h? It is 2 sine square h, and you have 2, it is h square. So I have not read, this is sine, this is h square denominator. So sine h by h whole square it is. So you can just apply the limit. You can guess, you can cancel these 2 and 2. So sine h by h whole square, limit h tends to 0, is going to be 1. So eventually, the sine theta by theta, limit h tends to 0 or theta tends to 0 is 1. Coming to right hand side, x by mod x. Since it is 0 plus h, you can write h. So it is h by modulus of h by h. So it is going to be 1. So left hand side, right hand side, 1, 1. And we have to equate it to the value of the function at x equal to 0, which is already given in the question as k. So this is f0 is k, so k is 1 from left hand side, right hand side. So k is 1 in either case. What is the answer? K is equal to 1. Find the relationship between a and b so that the function f defined by this fx equals to ax plus 1, bx plus 3 when x is less than 3 and x is greater than 3 respectively. So we have to check at x equal to 3, and on the left hand side ax plus 1 we are going to use, or right hand side we are going to use bx plus 3, and since it is 3 we'll use x as 3 minus h. Here we'll use x as 3 plus h. Okay. So h is very small, it is equivalent to 0. A into 3 minus h plus 1, here b into 3 plus h plus 3. So 3a minus ah plus 1, 3b plus bh plus 3, limit h tends to 0. This is AH, cancel, you can cancel it out, 3a plus 1. Here also you can make it as 0, 3b plus 3. So they are equivalent. They are equal actually, they have to be equal if it is continuous at x equals 3. So here you will get a relationship. 3b I am taking on the left hand side, this 3 minus 1 is 2, so 3a minus 3b is equal to 2. So you have a minus b equals 2 by 3, or you can just write like that. This is the relationship between these two. Okay, this is all about this discussion. Thank you so much. Take care of yourself.